Flat Earth Debate Uncut and After Show. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe. Hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they premiere, and there's also a PayPal, Patreon, crypto and thanks button in the info box below the video. Speaking of Patrons, I'm going to do a quick shout out to all of you who do support me on Patreon, so a massive shout out of thanks and appreciation to Phoenix Rising 86, Retro Bill, More Books, Cannabear, Fibre Oats, Bogey, Michael Kahn, Rob H, Ben White, John Kays, Patrick Gunnels, Banter, Will Brax, Mel B Styles, Troy Shuker, Hairy Blade, Neo the One, Rob W, Open Minded, Reese Pound, Del West Watson, Maria Neelands, Unbelievable Productions, Blue Ridge Ranger, The Real Gabster, Liam Redrick Jr., Abraham Mohammed, Adrian Quintana, Skeptic 936, Life is Short, Texas Mike, and David Wayne Foster. So another massive thank you to all of you for supporting me on Patreon. Now I will hand over to whoever is in Discord and Google so you can enjoy their dulcet tones while I set up for today's live show.
Our interaction the other day on the show, I think it might have been the pre-show. You gave me the independent variable as Earth turning, and I pointed out that the IV couldn't be manipulated by the researcher to see if that was the cause of the effect. Well, according to that standard, couldn't you also ask if there is any scientific evidence for the sun producing heat?
Yes, you can wangle that as a phenomena, but no, because who's making a claim of it and who's making a claim that it's science? So I intentionally positioned my argument to give you the opportunity to debunk it in that manner, or to put it another way, I led you in your rebuttal to my argument. But you have to have your opponent first assert science. So if you listen to the housekeeping questions, the only one that we ask specifically in regards to science is gravity. Further to that, we then ask if there's any hypothesis available from the means and fields that offer up heliocentrism. But the point is that they have to have an original assertion in the first place that there's science. Otherwise, you can't challenge them to provide an independent variable and claim that it needs to be capable of being varied. Now, I did, didn't I? I said that there's a cause and effect relationship and it's science, and because it's got an assumed cause, therefore science. That was my tact. But because I've made that claim, you're then perfectly within your rights to say, okay, well, if you say it's science, have you varied your independent variable? But if I don't make that claim, if I just say the sun produces heat, you might be able to describe it as a phenomena, but it doesn't mean I'm claiming that there's some scientific validity to the cause of that.
Right. So that's more or less what I was asking. I was asking if there is a way to scientifically validate if the sun was actually producing the heat, as we all kind of assume that it does.
Is it a how, why, or a what is question? That's the first step. Are you talking about an actual phenomena that has something going on that you could study the cause of? If so, is it man-made or not? If not, then it's open to scientific inquiry. And you can start assuming what might cause that, and then formulating hypotheses. If A, then B. As long as you've got an independent variable that you think will cause it, then you've got a viable hypothesis. You've got your presumed cause of the sun producing heat. All you're going to do is vary it and see if you can cause it to happen. I mean, that seems unlikely when I lay it out like that, but it doesn't mean it's not a valid hypothesis if you formulate it, assume the cause based on, reasonable logic, reasonable deductive logic, and then have a null. If A, your presumed cause, then not heat from sun. But that would be a valid hypothesis at that stage, more than any heliocentrist has for any of their claims when they do say science.
But the IV must be manipulated by the researcher, right?
Yeah, so to be an independent variable, there's a few things that you've got to qualify as being. So first, you've already said, capable of being varied and independent independently by the researcher, right? It's in the clues in the title, independent variable, so it's got to be able to be varied. Secondly, it's got to be real. It can't be gravity. It's not real. You can't. There isn't anything to vary and manipulate, so obviously it falls shy of being able to be varied by the researcher. So it's got to be real. And most importantly, it is your presumed cause of the effect you're studying. So to be an independent variable, you've got to be real, you've got to be capable of being varied and manipulated, and you are, by definition, the presumed cause of the effect that you're studying in nature. So that's what you've got to be an independent variable.
Right, and I don't see anybody manipulating the IV, which would be the cause, the sun. I don't see any researcher being able to manipulate the IV.
No, agreed, but by the same token, that's only useful if someone's claiming that they are. So in terms of pseudoscience and the assertions of gravity, someone's actually making a claim that there is science. So you can't just sort of say, well, part of the heliocentric model is in the title, heliocentric, right? Helios is the sun. So I can see your logic in your reasoning, but is anybody actually saying that that's scientific evidence of anything? If not, you can't challenge them and then pull apart their claim of science they haven't made. It becomes a straw man on your part if you do that. I've got your first slide up 10th once we're done with this discussion with Matthias. Whenever you're ready.
Yeah, that's fine.
Anything else, Matthias? If not, good questions. 10th, got sextant, altitude, and true angle. True altitude, sorry.
Yeah, let's just go through this and then we can come back. There's a few things I want people to see that at least I'm seeing over and over again. Sextant altitude and true altitude. When you take a site, the angle you read off from your sextant is called the sextant altitude, HS, to which certain corrections must be applied to obtain true altitude, HO. It is true altitude that is compared with the tabulated altitude, HC. The abbreviations stand for height sextant, height observed, and height calculated. DIP, height of eye. The tabulated altitude in the tables is given as if you were at sea level. But at sea, your eye may be 6 or 60 feet above it, depending whether you are on a yacht or a liner. The correction must be made to the sextant altitude to make it sea level reading. In small boats, it's usually about 3 minutes. It must be applied to all sites except those taken with the bubble sextant and the artificial horizon. This one reading was the basis for the trap, dip or not to dip, that is the correction, among other things. But before we move on, notice some key phrases here. Dip, height of eye, the tabulated altitude in the tables, okay, the books you go to make the corrections, is given as if you were at sea level. Okay, so it's all pre-designed, pre-computed for this. And then obviously it says the correction must be made to the sextant altitude later on in that same paragraph to make it a sea level reading. Now we're going to find out what implying the dingleberry or that you live on a sphere creates the problem here, rather than the obvious sea level as we all understand it. And we can come back to this later. Next slide. Anyway, that came from this book, Celestial Navigation for Yachtsmen, 12th edition.
Did you mean 3 minutes or 3 feet?
3 minutes, it's in minutes. The correction is in minutes.
Okay.
Just want to get the full book on screen. Just give me a
Sure,
second.
take your time.
Or the full cover. Good enough. So Celestial Navigation for Yachtsmen by Mary Blewitt?
Lewitt, I believe. And it's the 12th edition, so it's a book I keep running into when I do research.
Okay, I'm ready for the next one, if you are.
Okay, yeah. Dip. After the index correction, the first altitude correction applied to the sextant reading is for the height of the observer's eye above sea level. The higher the eye, the more the observer is looking over the true horizon, as shown in figure 910 below. The nautical almanac includes the effect of refraction in its correction table using. Sometimes everything's combined, so the one thing you do covers the dip, the parallax, all of it. Dip is 1.7 when it's in meters. Dip is 0.971 when it's in feet. The equations, the dip is in minutes of arc, and h is the height of the observer's eye above sea level. Since the effect increases the observed altitude, the correction is always subtracted from the sextant reading. Now you look at this illustration, you see true horizon at the feet of the observer, and you see observed altitude at the head or the eye line of the horizon, meaning where he would have the sextant. So there's your correction, but look what they got labeled as the true horizon. What do you see there? Flat baseline, right?
Flat baseline,
yeah.
Right.
That's correct.
Right. So now, then they stick in this angled horizon seen by observer that comes over to Dingleberry, which doesn't belong here based on all the readings, based on how angles work. They just stick it in there because sea level to them is this curved part of this Dingleberry. That's what. But then when they go to correct it, sea level is the true horizon, which is flat, if you follow. So here's the trick, and this is why everyone falls for it. That's a baller. Well, look, it's the observer is looking over. Now, I've been at sea so many times, I never see the horizon the way they depict it, horizon seen by observer here with an angle over a Dingleberry. I've never seen it that way. In fact, I've posted pictures of, in fact, you see one on your screen that just went away, where it's a flat horizon, a steady horizontal. No one ever sees this thing going over. And the only difference in dip is how high are you above that flat plane? It's not like this illustration is trying to show that you're seeing over a curve. It's nonsense. This is what we have to break down for the audience. Next slide. That was, I think, John Carl Navigation GPSH. So the following slide when you're there.
I'm there.
Okay, so now look at this one. Here's that true horizon shown with the bubble sextant, which is at the eye. I'm sorry, the one with the bubble sextant would be the observed horizon with your eye line. But the true horizon must match that, and that's the dip correction. But then they got this globe Earth with an atmosphere around it, with that shaded thing. Okay, but look at how they say you get an angle. You can't get an angle over a curved Dingleberry, so they got that flat plane. So that's the horizon at the eye level. And then a dip correction, which is how high you are above the sea level, is going to bring a parallel horizontal, which is saying the Earth must be flat. Next slide. So this one's busy, but let's go through it. So you've got the Earth partially shown as a Dingleberry, the observer's position, and then the horizon, which is a sea level flat plane right there, where an angle could be achieved from. Then you've got all the other things, but basically, what do you got? A zenith, perpendicular, a 90. But they got it on the Dingleberry. Well, it can't work on the Dingleberry. So they do a flat Earth measurement, they put it in the picture form like this, and it makes, because they're using illustrations and they're using words and a bunch of steps that you got to go through, everyone thinks it's actually, wow, echo. I'll try again. Everyone thinks it's actually working on part of a sphere, which it's not. It's inserted for no reason. Next slide. Observer's horizon. Listen to this. Figure 2.7, the nautical almanac and the site reduction tables assume that the sites are taken at sea level. So we just have to define what sea level is. For instance, from a periscope of a submarine barely emerging above the water. There's your dip correction. You got to get it there. Then you look at the other one underneath that, figure 2.8. The height of the observer's eye above sea level determines the dip, not curvature of Earth, not Dingleberry. The height above sea level determines dip. Why? Because previously it says the books assume sites are taken at sea level. This angle must be removed from the altitude of the celestial body above the horizon that is measured with the sextant. But see in the picture below, they've got the dingleberry to fool you. The picture above, they got a flat plane where it's actually an angle can be achieved. Do you see how they're doing this, everybody?
Excellent presentation.
Yes.
Any questions?
Yeah, George showed me a picture of it yesterday, and I kind of pointed that out about the downward angle where the guy's looking out from the ship at a downward angle. I was like, nah, that's bullshit. Don't know where you
Love
got
to
that
know
meme
when
from.
that
It's just
happens.
bullshit.
What was his response?
He tried to justify it somehow. I didn't pay any attention. I just knew it was bullshit.
Justify what? A straight line to a geometric horizon? Yeah, we know all about that, don't we?
The only
I
thing
think that's
that's
how he
happening.
justified it, actually.
No, go on, finish up.
A straight line of sight to a geometric tangent point. Au contraire, what is it? No Atmo day. All lines to the horizon are bent at a rate of 7/6 or whatever derivative they imply of the radius value. Straight line? No. Bent line for you, globe believer. Did you forget 2 years of chanting refraction at us? Asking us whether it was no Atmo day or not? What is it now? No Atmo day simply because they need a straight line to a tangent point we debunked? Unlucky.
The only thing happening is you have a depression angle when you're standing on top of a ship. If you're going to use your eye line as a fictitious horizon line, which is what the bubble sextant would give you, but no one uses that on a ship. So when you're on that ship, like it said, if you're on a yacht or a liner 6 feet to 60 feet, you've got to get your eyeballs on the ocean so that you don't have that depression angle and that your reference point is sea level. The reference point of a artificial horizon using the bubble is the eye line. So you've got this horizontal straight out from your eyes. You remember when I challenged the virus, is that line flat and horizontal and does it go forever? He said, yes. Well, it has to, because the GP of the sun has to hit it somewhere. And then that's your zenith distance. That's how you know how far you are away. Well, then if the correction is to bring it to sea level, it must be paralleling the horizontal. That makes the pictures I show of the true horizon that flat plane. So then why do you have this drawing of a partial dingleberry and an angle from the observer shooting over a curve when that is never the situation?
I'll tell you
'Cause
why.
it must.
Leave it
Go on.
rhetorical. Because they've got a second, non-physical, non-visible, only existing in the maths horizon known as Earth curve that isn't used in this method. That's why.
Yeah, that's there just to deceive people.
Of course. If you go to another slide I just posted, Nathan, the one that we're familiar with, it's the best copy of it too, by the way, if you want to keep it.
Yeah, sure.
They're always fuzzy, but this one's nice. So here it is. We've done this already. We just got to keep doing it, like the housekeeping questions. You need this box. You need this to happen. These are not diverging zeniths. Brian pointed that out. It's got to be this way. So whether that bottom line that they show slightly curving, which is really ridiculous because they're showing you a 90, you can't get a 90 from a curving baseline. So you see the trick is already being implied here. And then you got this shaded area as a circle of equal altitude. So you're somewhere on that circle with the GP of the star right in the middle. And that radius has to be a straight line. And so basically 90 degrees, height observed, complement angle, 90 degrees minus 60 degrees equals 30. So your angle is 60 degrees. But you can't get 60 degrees unless you're on the sea level, a flat baseline C. So if 1 degree equals 60 nautical miles on Earth's surface, okay, then 30 degrees times 60 is 1,800 nautical miles. So your zenith distance is 1,800 miles from where that star is directly over the Earth compared to where you are directly over the Earth. So when you're using the sextant, the mariner's sextant, and you have to sight using the horizon mirror and a horizon, you're actually using part of the Earth to do this. Your reference is the Earth, okay? Whereas in the bubble section, your reference is an artificial horizon, a bubble, a spirit level. So you do this with the mariner sextant. You take the elevation angle first, which then you minus from 90 gives you the co-altitude. And that's how you get your zenith distance. You don't get a zenith distance with the sextant at sea with the elevation angle. You get it only after you minus it from 90. Whereas if you had a plumb bob and a protractor, then you're totally skipping the horizon way of doing it and using your own zenith as the vertical. And the plumb bob obviously would be perpendicular to a flat baseline. And so there you have your zenith distance immediately with a plumb bob and a protractor. You don't go through this whole process. But you can't do a plumb bob with a protractor at sea. So you got to get the elevation angle first and do the subtraction method, because the only thing stable at sea is the horizon. And you got to have a reference. So hopefully that made sense for everybody.
That's good.
But as you can see here, you create this box and you have 90s. You got 4 90s here, basically, at each corner of each box. And this is from their own teaching.
Yeah, you can't get that if that baseline is curved. I'm sorry.
But again, just like sticking the dingleberry, they stick this little curved line and fool people as if it's actually happening over a curve.
Very deceptive.
Very deceptive, because you'll say, how can you put a 90 on the curved baseline? Well, you can't. Well, why did they? Deceptive.
Steph?
One more to round it out. I'll be back.
Okay. We've got a little while.
All right. But again, a review of what we did a couple of days ago. Do you have this one now?
I do.
Okay. Because when a transversal intersects 2 parallel lines, the alternate interior angles are equal. So if you go to the slide before, the one we just did, go to that, please. You see the 2 parallel lines. The one is the co-altitude, and the other one would be the baseline where it says horizon. Now go to the new slide. So there's that horizontal at the top, which is a reference used for the zenith angle, and a depression angle. You can't have a depression angle without a horizontal. So notice where the hot air balloon is. That's got to be a horizontal to get that depression angle from. And then if you're on the Earth, in this case, where the tree is, then you need that horizontal to get the elevation angle to the hot air balloon. Okay, now these angles are all the same. It's that box. And so now if you exchange the hot air balloon for a star or a sun, and you exchange the tree for an observer at sea level, voila, no curved dingleberry. This is how it works.
Amazing.
I'm done.
Epic. Thank you very much, 10th. Wow,
So what is it that they don't see? They don't see the deception, or they refuse to see the deception?
Who's they? Who
They
are you
don't
talking
want
about?
The
Yeah, they
ones
don't
that
wanna
argue
see it
against celestial
begin with.
navigation, I'm talking about.
I think it varies, Neil, on the person. Some people are open for discussion because they have doubts about how they get their news. Other people believe all their news and want to stay in that bubble and everything in between that.
Which brings me to yesterday. I got into a big argument with my brother the one that's in Alabama over this whole thing, because he used the thing that went on in Texas because somebody said it might not be or whatever. I don't want to get into it, but he just threw the flat earthers into that. And he started going at me.
Well, again, if that's his only defense, it's a non sequitur. Basically, as I see it, it has nothing to do with it. So, if the only defense is to lump it up with other things, that's not a defense on the matter itself.
He went to the Bible and said all the proof in the Bible showing you that it's a sphere, and you're not blessed. I said, whoa! What's all the proof in the Bible? And he brings up sits up on the surface, the circle of the earth. That's the only one.
Well, first of all, he doesn't know his Hebrew, Aramaic, Greek, or any of that.
He said the Hebrew says it's a sphere.
No, it's a circle.
Oh, no. It's a circle. There's a specific word for ball and sphere in Hebrew, and that's not used there.
That's right. So avoid your brother at all costs.
Yeah, and then he had the nerve to say that, the basic thing, that's not the important thing. It's about souls. I get triggered real fast and I start to scream.
No, not
which
you.
is not good.
Not you, Neil. You don't get triggered fast.
Because you know what it is? If you're gonna say something, then at least be up to date with what's going on. You're not even looking at anything on the other side. You're not even looking this way, and you're going to pass a remark.
Here's the problem. Scientism has come into the pulpit. They have taken pictures like the ones we show, but on other subjects, NASA, whatever. And they believe that as real science. They trust the source without vetting out the source. And then when we start challenging it, people like your brother and others go to resources on the internet, even Christian resources, who believe the pseudoscience. So they give arguments like circle means sphere when it doesn't. And then so they feel like they're armed and ready for you. And then they come to you and you say, well, let's look up the word. Let's do our own word search and not take anyone's word for it. Could it be that they have been fooled and circle is really two-dimensional? And that's what the Bible says. It's a circle versus a sphere. Where in the Bible does it say it's a sphere? It never does. But because their sources happen to be quote unquote Christian sources, they rely on that guy doing the homework when I want to do the homework. There's plenty of tools online where you can do the homework to see if what the information that they reference, actually vets out to be that. So I do this with everybody. I mean, you read your contracts before you sign them, or else you might get stuck with some small print, right?
I was doing a bit of this last night. Sorry, mate.
Hi, guys. Hey, Adam.
Hey, Adam.
There's a guy called Dr. Steve Mason, very respected scholar on this, and does the Greek translation. He was kind of explaining to dummies like me how complicated it is. He says he's going to use a bit of Josephus, so there's no intonations in terms of the Bible. But he says if you take the first sentence of this book, it's very interesting when you translate from Greek, particularly High Greek, which is what the scriptures will be written in, as well as Josephus. The way in which the Greeks is very literally brilliant to have as long a sentence as possible, which is useful in Greek because it has meaning and intonation. But when over the ages people have tried to render this into an English translation, it was just showing you how three different scholars have used three different techniques. So this one sentence is 254 words long. One scholar uses 10 sentences, one uses 5, one uses 12. And he says, which is right? Because when we're translating from the Greek, the most important thing the scholars are saying is to get the actual meaning. Because if you just do the words sometimes, it makes no sense. If you would like to try and translate into a 250-word sentence in English, it would just make no sense, if you see what I mean. But in High Greek, that's got literary merit But it does make it, as he was saying, it makes it very difficult for translation to the point that, you know, 3 top scholars will render that same text, trying to give it the same meaning in English, but give very, very different renderings of the text in doing so. Like I said, even down to the number of sentences.
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon, crypto and thanks button in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. One last time, if you're new to the channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now we are joined by Arwin, Neil, 10th Man, the Adam Meakin, and a whole bunch of people in Discord, so welcome one and all.
Good morning, everybody.
Hello!
Shalom.
Yo, 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 yo.
Praise be to Allah. Any evidence of a physical...
Allah Akbar.
Any evidence of a
God is
physical...
good.
Right, let's get these
Namaste.
What's going on here?
random religious
I was
greetings
going to
out of the
say
way.
Must be with you.
I was going to
Bacon
say
and more
hi to
salami.
Armenian.
Bacon and more salami.
Welcome, salam. No.
Gotcha.
We all done with the religious greetings?
I think so.
Excellent.
But it is.
Hakuna
Oh, mate.
Matata.
That's even better.
You say Hakuna Matata?
Yeah.
Very good. Means no worries.
The rest of your life.
Any evidence of a physical geometric sphere edge? That's a horizon, formerly known as Earth curvature.
L'chaim.
In English, if possible.
Oh, okay. Sorry. No, impossible.
Go on, we're going to have a bit more enthusiasm about this question. It's asserted that there's a physical limitation to our view at the horizon, and that's Earth curve getting in the way of stuff. So you're telling me if I
Earth curve.
ask, although I do ask this on a daily basis, so increasing the enthusiasm level temporarily at the moment is not beyond my capabilities. But that is claimed to be Earth curve, right? The horizon.
Well, like I've said before, I wouldn't be on your show as a panel member if I actually have seen Earth curve.
But yeah, they claim
Not
both.
since Black Swan 2020.
That's what I was waiting for. Right on. If the Earth was a sphere with a radius of 3959 miles, then every distance to that horizon, that would be Earth curve, could be no more than 1.2 times the square root of the observer's height in feet. That's the distance to the geometric horizon to block boats and buildings, aka Earth curve. However, in the Black Swan imagery, the horizon is beyond those geometric limitations of a sphere Earth radius 3959. Therefore, the horizon is not Earth curve.
Yeah, that's all great, and the math supports it. But Just ask anybody, have they ever seen the Earth curve? The answer is no. In fact, Neil deGrasse Tyson says you can't see it at all. Even if you're 60,000 feet in the sky, you can't see it. So
He's lying.
Hold on.
He's lying because the horizon is claimed to be Earth curve in the heliocentric model.
We have a problem then, because my brother said to me yesterday, no matter what, even if Elon Musk or Bezos has said that he will bring anybody up in space to see the horizon, and you still will not believe.
Refracted and geometric, he's missing the word horizons, are not mutually exclusive. Well, they're not mutually inclusive either, because you'll need your refracted values based on R in order to derive the second horizon that we don't see. That would be the geometric horizon. Well, that value gives you R. That's R, in an essence, part of your refracted value. So when you say they're not mutually exclusive, no, you depend on being able to see a geometric horizon to measure it, to derive R. But if you can't, paradoxically, you can't then get a refraction value to refract it into a non-geometric position. But when you refract it into a non-geometric position, it's no longer geometric. That's the point. Thank you for your comments all the same, Phil.
Phil's caught up in the paradox. He can't get out of it again.
Here's the paradox on screen right now. So this is Andrew Thomas Young's description. And if you read along the top, it says, we've drawn a... Who's making that bloody row? I bet it's Neil.
Sorry.
Just mute. Just your crappy, horrible mic dragging all over everything. Not only does it drag over everything,
I
make a
was
horrible
on
noise.
mute.
Yeah, but you're... Okay, so Andrew Thomas Young's diagram, and he says, we have drawn a line of sight to the geometric horizon, right? So a line of sight to the apparent horizon as the straight line OG. So the two words in there that are important, 3 if you include straight line, all right? Apparent, that means you can see it. Line of sight, that means you've got a line of sight to it. Well, that's the line OG. Well, paradoxically, this whole diagram is to explain why you don't see G. Why what you actually see is OH, a bent line. For all you fundies telling us how you can have a straight line of sight, unfortunately not. Andrew Thomas Young goes out of his way to explain how you can paradoxically have a line of sight to something that's refracted to point H. You haven't got a line of sight to it, have you? You need one because the line from G to the centre gives you your radius. It's Al-Biruni's dip measurement with a straight line of sight to a geometric tangent point at G. That Andrew Thomas Young's explaining why we can't see it. The actual line of sight, according to this diagram, is OH to a refracted horizon. We only have one horizon. You can't see two. So therefore, you do not have, as described here, a line of sight to OG. This dotted line isn't visible. You don't have a line of sight to it. So that's their paradox.
I mean, they've said it. It only exists in the maths. So Andrew Thomas Young is really just pushing a thought experiment here.
He's pushing two horizons. He's saying you've got a line of sight to a geometric horizon and a line of sight to a refracted non-geometric horizon. According to him, line of sight OG and line of sight OH. Two horizons. We only have one. The horizon in the begging the question, proof of nothing perspective hijacking Earth curve maths is OG. A straight line of sight to a physical obstruction known as Earth curve. Debunked by this very diagram. Paradoxically using a refraction rate that's based on G to the centre point of a sphere Earth. That's R. Radius. Can't get it if you can't see it.
But that's my point, Nathan. Since it doesn't exist and they must prove somehow to themselves and to others we live on the dingleberry, it's a thought experiment and only exists in the maths.
I'm going to allow a bit of begging the question to them to pretend that when you see these black swan images, that H is the point where the horizon is, even though it's further away and past the geometric obstruction. Even still there, they're reifying the horizon as H, as the leading edge. It's just further away, but it's still caused by the geometry, which is why the black swans are devastating, because that Black Swan takes the geometry for an R value from 3959 to 250,000. If you allow them to beg that question a little bit and apply it to a picture, to reify the horizon there with 7/6R, it still means that R value is astronomical.
Adam, did you mean 40,000 and that the circumference would be 250,000?
No.
I thought it was 40,000 radius with the Black Swan at 10 miles out.
No, the Black Swan takes it to 250, doesn't it?
Yeah,
I've
250.
got to stand corrected. I can't.
No, you're correct. It's 250. I've got to expand on this because you've honed in on it without enough detail. So what Adam's describing is the orbital path of the moon in the heliocentric model. So if you imagine that thought experiment where you hold up an apple and then get somebody with a golf ball to step away probably 30 paces, maybe even more, quite some distance, and hold not a golf ball, maybe a pea, and they go, right, that's the comparison of the distance between Earth in the heliocentric model and the moon in the heliocentric model. Now, if you went another couple of steps and then made the apple now effectively the size of a car parking lot, that would be the circumference of Earth if you based the horizon measurement in the Black Swan on an R derivation. That would be the size of Earth beyond the orbital path in the heliocentric model of the moon. That's how big Earth would blow up to be if the horizon was still being reified into a geometric limitation in the Black Swan imagery. Beyond 250,000, I think it is, just as opposed to the moon, which is just under in the heliocentric model.
But that's allowing them 7/6R, but they don't face up to that point that even if you allow them to beg that question and you give them that bit of math, it's still so far and still fundamental within their claim of 7/6R is it's still part of the geometry that's causing the horizon. It's still a piece further back that renders flat, but it's still a physical obstruction. So if you extrapolate that out, that's how ridiculous a picture like the Black Swan turns the maths into.
To put it more succinctly, we have debunked Earth curve. An Earth curve is a fundamental premise of being on a sphere. It's the horizon in your model, or it was, until we debunked it in 2020. Now it's not. Lumpy Gas and Vacuum, thank you very much for the super chat. Thanks for thanking me. Says thanks, Nathan. And panel, I'll add to that, but thank you for the super chat.
Well, isn't that going to bring in a host of problems since they can... Well, they have to change everything about their heliocentric model if the radius of the supposed ball is not 3959. Everything changes.
Not exactly.
Nothing
yes and
works.
No. They can't change anything in that regard. So yes, they can scale it differently, but they can't change what they've reverse engineered into being an R value. It works with the angle measurements to Polaris. Well, they won't change, will they? But beyond that, you could potentially change the scaling values in Kepler's third law when you get the maths for distances to the sun, and they have changed in recent history. So we know they can change the scaling values.
Yeah, but how does that affect all their calculations?
It doesn't. You can put up, if you, at the moment, Venus is assumed to be Earth's twin, therefore have Earth's radius. But you could change that value very easily, couldn't you?
Well, didn't we have this discussion yesterday where we just changed the model, that lady said?
Yeah, that's what I'm saying. If something's anomalous, you can just say, all right, well, we'll just change one of these scaling values. It doesn't actually affect anything because you can label the distances of whatever you like. Once you've figured out the motions, then you just have to apply the mathematics with a scaling value. If you don't know how far or how big Venus is, you've just got to make it up. Well, but you can make it up at any value and still apply Kepler's third law of interplanetary motion to derive the scaling values. Therefore, it actually matters not how far the sun is. It could be as close or as far as you like. Like in 1984. The sun can be close, it can be far away, whatever our mathematicians decide.
Didn't they do that with the orbit? When the so-called orbit, they had it as a perfect circular orbit, didn't they, at one point? and then they ran into some trouble and they had to change it into not such a spherical orbit to compensate for another problem that they come across. So yeah, they're just always changing things and altering things to suit the so-called model.
Exactly. Shout out to Retro Bill. It says, hard to believe Eratosthenes is still the most common globe proof cited by normies when I speak to them, or whom I speak. Yeah, Retro Bill. Hopefully you point out that that's a flat Earth angle measurement. I hope so, because that measurement proves a flat Earth. Shout out to Godzilla37, who's thanking Neil. I'll thank Neil for you as well, Godzilla. And thanks for the super chat, both you, Retro Bill and Godzilla. Really appreciate the support. Thank you very much.
Well, let me tighten my argument a little bit. So it must match celestial navigation because we use the stars and sun and so forth for navigation. And you got to have a 90, and the furthest distance from 0 to 90 at 60 nautical miles is 5,400 nautical miles. So if the Earth is much bigger, that destroys everything.
The Earth can't be bigger.
Right. So it's over for them because the black swan shows what? Many Earths. I mean, one is 10 miles out, one is 20 miles out. We got many black swans. The Earth keeps growing in size.
Right. You can't go beyond the physical limitation of a hill in the way. So if you've got a foggy day and you've got a geometric measurable hill between you and something in the distance can be reduced. You can have poor weather, so you can't even see the hill on a given day. But it'll never be the case that the hill is beyond where it's supposed to be. Well, the hill in Earth curve terms is the horizon. That's the hill that's geometrically claimed to block your view. And it wouldn't matter how clear a day you get. Makes no difference. It's a geometric limitation to your view. So you can't have it beyond the thing it's supposed to block. That's like waking up one day, looking out your window at the hill, and going, my God, the hill's behind the stuff it used to block. It's just not, that's not physically possible.
It's like the horizon, though. If you look at the word horizon, horizontal, and the sun, they used to call the sun Horus, and they used to need to know where Horus was. Horus is the hour of the day, and they used to work out the hour of the day by measuring the angle of the sun from sunrise on the sea level. They was measuring angles then to give us the time of where Horus was, horizon. So at 0 to 30 degrees, that in the daytime would correspond to, say, between 6 and 8 o'clock. And then from 30 to 90, 60 degrees, that would give you another hourly rate. So they've always used angles, and you need a flat baseline for that angle. So they've always used the sun and a level baseline, even for working out the time at the beginning of time.
Horus.
Horus, yeah.
It's just the way you're saying it, like Norris. You're saying Horace.
Yeah, it must be the Manchester accent coming out.
Yeah, I'm being hypercritical. Indeed, excellent knowledge. Any evidence of the distance to the sun?
It's over there for now.
It is. Moving on. No, seriously. We're talking about angle measurements, right? Getting distances when we're travelling along the ground. And how we need parallel lines to the sky. That's right, ladies and gentlemen, the flat sky, in order to measure the angle and figure out how close to the horizon it is. But surely that would leave us with a height, would it not? Someone's at my door.
Not really.
Can you take over 10th just for a second?
10th?
Yes, obviously you had to take a phone call. So in celestial navigation, at least from the books, height doesn't matter. So they leave that out conveniently. So they just want the angle using a flat baseline for the GP of the sun somewhere over the earth. And then the GP of the observer is the zenith position of the observer. So both the sun and the observer have a zenith position on this earth. You can't have diverging zeniths on the globe work because they can never get an angle. So they're talking two sides out of their mouth there.
That's why it's come down to, it's basically come, I think the discussion and the arguments got quite simplified. If you're even using Eratosthenes, Alberuni, and the sextant, it all just comes down to using angle measurements on the physical surface of the Earth and obtaining large distances of that baseline, which all require an angle, which is two straight lines. And that's how simple it's become, really.
Speaking of which, any evidence of axial rotation, Earth-based variety?
Stars move 15 degrees an hour drift.
So the stars are moving.
Yeah, not actual. I said 15 degrees an hour drift. That's not actual deflection.
Right, but the question is, any evidence of axial rotation of the Earth-based variety? The Earth is not moving. Is there any evidence of the Earth
No,
moving?
no, that's the claim, isn't it?
Yeah.
The claim is the 15 degrees an hour, not actual deflection of the stars, isn't the stars moving, it's the Earth moving on an axis.
Hold on, Nathan. Are you saying the Earth rotates?
On an axis at 15 degrees an hour. I'm not saying it, no. As before, I am not a globe believer. But that is the claim. The claim is that motion, that's Coriolis deflection. That's Earth turning beneath the stars. 15 degrees an hour drift. Earth as a non-inertial turning reference frame. The stars in the inertial reference frame. The apparent deflection appearing as a circular motion in the sky. That's not actual deflection, that's Coriolis drift as a result of Earth turning beneath them.
So then you're describing drift because the Earth is turning, correct?
It's not actual deflection. The stars aren't really moving, although in a different setting, in a different reference frame, you could describe them as moving just to add confusion. But ultimately, what we see in the motion is only as a result of Earth turning beneath them. That's Coriolis deflection. They're not moving, we are.
Right, so then drift is what you're saying is going to happen because we're moving, correct?
That's what it's called. It's called Coriolis drift.
Okay, so what about a hot air balloon or an airplane? Anything?
They don't exhibit the effect. They're not happening. That's not happening to them because reasons.
Because reasons?
Yeah.
Can you give one?
Because when the hot air balloon leaves the surface that's non-inertial and should exhibit drift, what actually happens is the watching of not actual drift is now going to transpose itself into actual deflection of the hot air balloon and how the air moving with a sphere Earth, I assume, has Earth moving with it, violating the first law of thermodynamics, is actually exhibiting no effect to see, and that's perfectly reasonable. It's called it's called the conservation of angular momentum.
This is fun. So you have drift when you want it and no drift when you want it. So you have both sides of the argument.
That's correct. If I need to example drift in any way, shape or form, I can point at a gyroscope, a bullet, a football, or the stars and say the Earth is turning and we're turning underneath bullets, we're turning under footballs, we're turning underneath the stars. And if simultaneously you point out that we're not turning underneath aeroplanes, not turning underneath hot air balloons, and not turning underneath drones, I'll say it's because those specific examples violate the first law of thermodynamics. That's correct. I will have my cake and eat it.
That's funny. Awesome. You want the rest of the questions or you want me to keep asking?
I don't mind either way. You decide, as you've done such a good job, I assume, while I was bringing an Amazon delivery in.
Well, it's up to you. I can go if you want.
Yeah, why not?
All right. Any single viable hypothesis from any of the fields of cosmology, astronomy, or astrophysics?
Got plenty of phenomena.
Yeah.
Those stars drifting, that's a phenomena. And I've got science that says it's as a cause of Earth turn. You know, if you use a gyroscope, which is spinning in a fixed frame of reference and doesn't move outside of that spinning frame, if you stick it on Earth, because Earth's turning, you'll see that the gyroscope drifts at 15 degrees an hour as a result of the motion of Earth underneath the spinning gyro. So the gyro keeps spinning in its same axis, in the same position, but the cage attached to Earth makes it look like it's drifting, i.e. the gyro's drifting. It's moving in the cage. That's actually because Earth is turning underneath as a second reference frame to the gyroscope, which is in the inertial reference frame. Same as your bullet and your football and the stars.
Have you run this through the scientific method, or is it just stops at the observation?
It's called an experiment by a man called Foucault. So, I mean, what more do you need?
Oh, okay. So why does that satisfy the necessity of an experiment? Do you know what a hypothesis is? Do you know what IV, DV, CVs are? Did he do all that?
Yeah, he's got all of that.
Can you explain it to me, please? What did he vary?
I've already gone through it, but I'll happily go through it again. You spin up what looks like a spinning top. Or if you imagine a bicycle wheel that you spin up and perch on your finger, you can tilt your arm, you can tilt it left and right, but the bicycle wheel still spins, right? In the same plane. It doesn't tilt itself because it's spinning. It's got gyroscopic motion. Well, you do that on a smaller scale with a smaller gyro that you can get going much faster. And then you plonk it on anywhere on Earth. And, you know, basically the cause of the drift in the gyro is because Earth turns underneath. So you've got your cause and effect relationship established there, proven by the gyros drifting. What more do you need? That's science, right?
How about a demonstration of that actually happening?
Yeah, we had some. Bob Nodell showed in a fibre optic gyroscope that once it's spun up, it demonstrated a 15 degrees an hour drift. That's the Earth moving underneath the fixed spinning frame of the optical gyroscope, to the tune of the cage moving at 15 degrees an hour in line with the Earth turning at 15 degrees an hour.
I didn't know he was standing on the North Pole when he was doing that.
It doesn't have to be. It can be anywhere on Earth.
Yeah, he would.
Is the gyro a man-made thing or naturally occurring in nature?
The deviation at 15 degrees an hour as a result of Earth turning underneath is very much a natural effect of Earth turning.
So then what would you have to manipulate to find out if that's true? Wouldn't it be the Earth itself, not a gyro, man-made object?
I can do either. I choose to just vary the gyro though, 'cause it's easier.
You can do either.
No, I can't vary the presumed cause of the effect. My assumed cause, if I'm going to call it science, even though I've got no natural phenomena beyond the stars, is that Earth's turning beneath. Well, if that's the IV independent variable cause of the effect being deviation at 15 degrees an hour, not actual deflection, Coriolis effect, well then I've got to be able to vary that which I assume causes the effect. To be an independent variable, you've got to be real. So Earth turn, real? Well, you might be assuming it, so let's just move on to the next, which is that you've got to have it as your independent variable in your hypothesis. Yeah, I can qualify that. Yeah, Earth turn, independent variable. Yeah, I've done that, I've covered that. What about the last, which is to be able to vary and manipulate it as a researcher? Can I vary and manipulate Earth turning as a presumed cause of this effect? 15 degrees an hour drift in a gyro, definitely not phenomena you observe in nature. No, I can't. I can't vary Earth turn. I can't vary the presumed cause of the effect to validate it scientifically. 99 people, come on, one more, 100 watching, woohoo! Shout out to all of you who shared the show. That's the only reason there's 100 people watching, so thank you very much of all of you who are regulars that do smash the share button. But if you've just joined us, a very warm welcome to you. Glad to have you. Please smash the subscribe button and share button. That's why you're here. You've seen someone sharing the show, no doubt. But yeah, thank you very much. Please share the show.
Moving on, any evidence of a self-perpetuating molten iron core at the center of a presupposed spherical Earth?
Let's ask the mob.
No, they've only dug down 12k.
That's what you think.
All right. Any evidence that you can have gas pressure without the necessary antecedent of a container to press upon?
Question to my brother, and he refused to answer it. Atmosphere is different, don't you know?
Atmo, air, sphere. Air doesn't take the shape of a sphere, so when someone says atmosphere is different, well, it's an oxymoron.
That's correct, and that's what I said. and he refused to engage. He still swears that Bezos is bringing people up to see Earth curves.
Is Bezos the one involved with Amber Heard or the one with a penis logo? Which one's Bezos again?
Penis
The
logo.
penis rocket man.
He's the one with the feather.
Yes.
They're
Yeah.
laughing at you. If you're watching that guy, right, he's got dick subliminals all over his shit. I mean, they're just laughing at you.
Yeah, but what is he? When he takes them off, what are they seeing? They're not seeing anything.
But I would love to do that. Of all the things I would love to do before I die on my bucket list, getting up as high as you possibly can would be one of my desires. Not because I in any way think that the black area is a sky vacuum. It isn't. Tenth Man just covered that in the housekeeping question. Wouldn't you? It's one of those things I remember. It's part of my, like, when people interview me about how I came to this subject, I'd tell them about how I was on backs of planes looking out the back window, the emergency exit window, because there's no seats around it, and you can get a really good angle, even though it's a tiny window, on the world below you. And I remember thinking, God, I wish I could go higher. And one of the reasons I thought I wish I could go higher was because I was a reasonably well-educated heliocentrist. And was under the understanding that from a commercial height, commercial airliner height, you couldn't see Earth curving. That would be the horizon, the physical limitation to your view, Earth curve, that you couldn't see it bending, i.e. becoming the sphere below you, until you got much, much higher. And even then, you'd only see it to a very small degree. But I still wanted to see it. So when you have Math Powerland saying Earth's flat, you suddenly have all these memories of going, oh yeah, what was it they said about why I couldn't see Earth as a sphere again? What was their excuse for not seeing it? Oh, because you're not high enough. Meanwhile, we'll calculate it at 1.2 times the square root of the observer's height in feet and claim it's blocking boats and buildings.
Yeah, that's a joke. And let me ask you a question. What do you call that when people are just arguing from one side and not looking at both sides? Isn't it ignorance?
Zealotry?
When I went up in a plane, though, the first thing I thought of was, how could Earth be a sphere? Because I was just looking at flat land and flat ocean.
I was bad. I was like, where the hell is the damn curve? As a kid. Like, why don't I see this curve, man? That sucks. All
Yeah,
excited.
But
it didn't shock you how flat everything was, though?
That's
it
what
was
he's
more
saying.
shocking to me how incredibly not drifting we were. That's what I noticed the first thing.
That's what Chocolate is saying. Chocolate paid for it.
Drifting.
Chocolate.
We're not supposed to drift. We're supposed to observe things drifting. We're not supposed to notice that we're turning. That's why it's used with Coriolis. So when, again, you've got to wrap your head around, I think it was Brian that was asking about this last. Why is it called non-inertial, the turning reference frame? If you're on a roundabout watching a ball tossed between two people over the top of it, what you're looking at in the ball, is it looking like it's curving? Because you're spinning, right? That's the effect we're talking about. Why would you describe that as being observed from a non-inertial reference frame? Well, let me explain how it's a non-inertial reference frame first. If you're on the roundabout and you look down, so you put your hands either side of your head so you've got tunnel vision, and you look down at the floorboards, what you see is nothing happening. You and what you are standing on are as one. There's no movement. Yeah? Now, you have to have that as your frame of reference in order to describe the ball curving. Why? Because the ball isn't curving. So to describe the inertial effect of the ball curving, you have to describe that motion, actually your motion, in an object that has no motion applicable to it. So there's no curve in the ball when you watch it spinning underneath it from a roundabout. But to describe it, you have to describe it like you're not moving and it is taking the motion you're observing. So you observe it curve, it's an apparent curve, but it's not really doing it. So in physical terms, you can't describe it ever as having a curved path because it doesn't. You're the one moving, but what you're seeing is the effect of your movement, but with the understanding that you're not actually moving at all. Hence the effect of the curve. Hence the description as non-inertial. Not as good as Paula's explanation to me, but as good as I can muster on the spot.
Also, if the Earth was a ball and pilots were flying, we all know about they'd have to adjust for the curvature and dip down. Now, you wouldn't, if the Earth was a ball, you wouldn't expect a pilot to do that. There'd be a piece of equipment on the aircraft that would do that automatically, and there isn't.
Well, they treat Earth as flat, and there's a good reason for that. Because if they didn't, what you've effectively got is more space ahead of you, dropping away from you. Well, if you have that misapprehension that the ground is not flat and in fact falls away, that means the ground ahead of you is getting out of your way at 8 inches per mile squared. That means you've got more space to fly in. So if you take that as read and start going, well, beyond that horizon, there's an extra cavity that I can fly in. Well, no, there isn't. If you take that as the case, then you're going to crash into the ground. So no, they absolutely do not treat it as anything other than a flat plane when they fly above it. Because if they did, they'd consider there being more space to fly than there actually is.
I think I think by now somebody, whether accidentally or purposely, would have said, you know what, I'm just going to try to fly off into space and just keep it level, right? Because if you keep it level or straight, the ball's going to fly. It's going to drop away from you, and you're going to end up in outer space at some point.
Right.
I don't know how that hasn't happened yet, but
exactly.
I was on a plane. I was on a plane going to a golf tournament, and it was a private plane with a golfer and so forth. And the pilot went up to 23,000 feet, and as soon as he got there, it was level flight, and he said on autopilot. And I started asking him these questions. I go, so you obviously can talk now, because he asked us not to bother him until he gave us the clearance to talk. And we all had headsets on and so forth. So I'm in the back looking at his instrument panel, and I see that the wings are level with the horizon. And so I'm seeing level flight. And if you poured me a drink in a plastic cup, I'd see the water being level, just like we experience on an airplane when they say, okay, now you can order a drink because we're at level flight. So then for the time duration until he took it off autopilot, it stayed at that altitude, and we were flying straight. So there's no going into space, any of this stuff, because it's not what they say it is.
you are now free to move about the cabin.
Yeah, I was going to say earlier, Chocolate, you paid for an e-ticket ride on an airplane, and you still didn't see the curve.
Is there any evidence of the R value? I don't think we covered that in housekeeping.
No, I was going to go next. So let's go with that one then. Any evidence of Earth radius, the R value?
No, we debunked it. 2020. We also now have moved on beyond debunking their claim of radius on a self-perpetuating molten iron core-based sphere Earth, and moved beyond it to how they got their R value, which we debunked with the black swan, and it came from a flat plane.
Wouldn't that be sufficient enough to destroy the globe model when you destroy its R value?
More than that, it proves we're on a plane. We debunked it in 2020. The Earth curve is a necessity. It's a natural consequence of Earth being a sphere with a geometric limitation to your view. That's what they use to claim it with their maths. Well, the moment you show that it isn't, there is no longer a physical limitation to your view at the horizon known as Earth curve, then there isn't any Earth curve anymore. What's that you say? Oh, we wouldn't expect to see it from 40,000 feet. No, the horizon's not Earth curve. Doesn't matter how high you go, Earth's never going to go into a big ball shape.
Any scientific evidence of gravity?
Which one?
I'll let the audience answer that one.
Does mass not attract mass? Is that not a natural phenomenon we observe? Gas go down, go boom, boom, right? It's attracted to the mass of Earth.
What's mass?
I don't know. You tell me, you define it. It's your claim suddenly. I haven't got to define this. Blah, blah, blah.
Well, how many types of gravity are there now?
2.
So Newtonian and Einsteinian?
Yes. 3 space and 4 space.
When I explained this to my brother, he had no clue that in higher education, that's when you get taught it's the bending of a concept.
Did he go through higher education?
He's self-taught, so I don't know if he even
Well, no, then he wouldn't know. How would he?
Well, that's what I'm saying. He's arguing in ignorance, not even hearing anything from outside.
That's where Anthony does well, because Anthony's essentially going out, and if you want to look at it from one perspective, he's talking about how the current rhetoric of gravity is Einsteinian, taught to people in higher education to get their qualification, to go and teach 107-year out-of-date mass-attracting mass, when they've just literally been taught how gravity is not a force, and how the conceptual medium, known as pseudo-Riemannian force space-time, is bending as a result of the uneven distribution of mass. That's what they learn at a higher education level. So then they just ignore it all and go and teach the curriculum that mass attracts mass. Falsely ascribed to Newton, actually C.V. Boy's Reverend John Michell and Cavendish gravity.
Nathan, in most other disciplines, when someone is presuming a cause of something and later find out that that was false and the true cause is established, do they continue teaching the false cause for over 107 years?
That hasn't happened with gravity. They haven't even gotten a phenomena anymore. They used to claim a phenomena. Mass attracting mass is a phenomena that just doesn't happen. It's defied by gas law and gas behaviour. Gas has mass in their claim of their description of what it is, even though when you actually ask them, you get an equivocation between mole and inertia. But either way, they think it has mass. And whatever mass may be, they're claiming that that goes down. But gas doesn't behave that way. It was violated 107 years ago and replaced by Einsteinian pseudo-force space, a conceptual medium known as space-time. Length, breadth, depth and time. Well, that replacement means there is no phenomena anymore. There's a description in a mathematical pseudo-force space.
Again, my question was more of when you find out it isn't something, but it's something else, do they teach the isn't something for 107 years? Or is that
right,
done
I see
on
what you're
purpose?
saying. You're saying when they find out that phlogiston isn't real, do they still go on to teach it at primary school level? No, they don't. It's absurd.
Right, so why are they doing it?
Because they need you to be under the misapprehension that mass does attract mass. So when you're asked why the gas would not fill the availability of volume, i.e. space, a sky vacuum, 10 to the minus 17 torr, you'll hark back to your very primitive education in this regard when you were very young and think, nah, gravity sorts that out. That's not a problem. The gas comes down, and if you look it up, you'll see gas described as atmosphere, and a whole bunch of laws applied to the paradoxically sphere-shaped air when air takes the shape of its container. It doesn't take a sphere shape, but they'll describe these ever-increasing volumes of homogeneous sphere-y layers that go up and up and up until you reach the Kármán line. And then suddenly gas stops behaving as gas does. Just reaches the Kármán line and goes, you know what, I've had enough. I'm not going to continue at a high rate in whatever direction I'm going. I'm just going to chill out here at the Kármán line. Maybe go back down so that they can achieve yummy gas pressure to breathe down on Earth. Obviously, I'm now moving at a vaster rate than I was when I left the ground because I'm keeping up with the ground below, so there's no effect in Coriolis. I mean, I'm doing all kinds of crazy shit at the Kármán line, says gas, when it's sentient.
Well, what do you want? What do you want from rebellious gas particles? I mean, they do what they want.
They're there at the Kármán line burning their bras in defiance of natural law. Yeah, that's right, Chocolate.
Well, we're at 44 past the hour. One last question.
There's
Any
one
evidence?
bit to add.
Go on.
Only to come back to I get very discombobulated when Nathan's playing bit all this. It throws me off. I don't know what to do. On that point, there is the point that if you are going to pretend that somehow a gas particle is like a theoretical space rocket and needs an escape velocity, and that suddenly as it goes higher, gravity does pull and slow the particle down, so it does finally turn around. There isn't a point, as far as I can see, where you could apply that with thermodynamics or any parts of bloody phone. So, any parts of how gas behavior actually works and how temperature relates to and how molecular speed relates to it and what zero speed for a gas particle would mean, which would be being at absolute zero. Now, to turn around, there has to be a point of absolute zero so that the can go back the other way. There has to be a 0 point, which is an impossibility in gas behavior. So to fit in to their model, they have to again deny further natural laws of gas behavior. It's sort of nuanced, but there is that turning point would mean 0 energy point, wouldn't it?
I think what you're describing is that if you're false in one, all the other things break down. So obviously, they're assuming we are on a globe, we're in an open system next to a vacuum of space, and somehow these gas particles are protesting at a certain height if they're sentient. It all falls apart if you're wrong on the premise that you're on the globe next to a vacuum.
It started with a particular premise, didn't it? What Adam said was, you have to start with the assumption that the gas would require or be necessitated to escape, and he described it as achieving escape velocity. Well, escape from what? The fact that they're falling in an orbit by assumption?
Well, they're being pulled in. The theory of a rocket is that the force of the gravity that's why you have to go so fast to escape past that, otherwise it'll just pull you back.
There we go. There it is. There it is. So, okay. So what we've got in terms of the comparison is a force that has to be overcome, right, Adam? Bit like Newtonian forces of gravity that would need to be overcome, right?
Yeah.
Is gravity, in the truest sense of the current understanding, a force?
No. But you can think of it as one.
I don't want to think about it. I'm just being matter of fact.
Then no.
So the bending of a conceptual medium known as space-time, that's not a force.
No, it's just...
Yeah, that word conceptual just messes that all up.
But do the rockets have to escape a conceptual medium?
No.
So what force are we talking about then?
We're no longer talking about a force if we go to Einstein, and we're talking about, this is not my geodesics and how we have to get away from the bending straight line.
No, well, fair enough. Let's not concern ourselves too much with geodesics in space-time then. And let's concern ourselves with the more colloquial understanding of what that means, right? So when we're measuring the force, because there is still definitely a force on Earth, how would we measure that force?
Torsion bar twist.
You're going to need the fabric. The fabric to bend the space-time.
Torsion bar twist we can come back to. Good answer. But would it not be weight?
No, because I've got to assume gravity too.
What, within weight?
Yeah.
Well, let's do that. Let's just assume it as a force, right? You said we can think of it as a force. So if we now think of it as a force, is it a downward vector at 9.8 meters per second squared by any chance? Just so I can think of it that way.
It could be expressed like that as an approximation within Newtonian.
So we're back to 107-year out-of-date rhetoric.
Yeah.
But isn't Einsteinian?
Sorry.
I'm sorry. No, I was going to say, isn't Einsteinian that 9.8 meters actually the Earth going up?
Yeah, but we've moved away from that because we didn't want to cover geodesics in space-time in terms of the motion through fourth-dimensional space-time of Earth in a geodesic manner. That would be a curved path.
Well, I'm just bringing it up because in the new gravity, it's the Earth going up that gives a 9.8, and then the one that Newton did is coming down with a force. So it can't be both.
And just to
I don't think
back up Tim
Einstein
on this,
literally
it's
said-
not.
Wow.
Before you people think that it's some flat Earth nonsense, right? Flat Earth society nonsense with the Earth rising up. Check out your heliocentric priest Brian Cox, who actually agrees that that's what Einstein is saying. That the apple didn't fall to the Earth. The Earth actually went up to meet the apple.
Yeah,
Straight from the horse's mouth.
I was about to go into exactly that with Arwin, because Arwin was about to say, I assume, he might now deny it. Well, Einstein didn't literally say the Earth was meeting the apple, did he? Yeah, he did.
Doesn't he say...
No, but that's just based on relativism. It's just like, oh, it's all relative, so I can think of it as if the Earth is moving towards the apple, just as the other way around, because it doesn't really matter. It's just Einstein screwing around with this mathematical conception.
That's correct. That's correct.
The maths doesn't distinguish which is... It calculates. I could be wrong, but it doesn't distinguish which way. It could be either for the maths. The maths, it doesn't matter, I don't think, which is going. It's relative, isn't it? So within the mathematics, it could be one, it could be the other, but the maths doesn't make a distinguishment, I think.
The mathematics do, yes. It's an inertial vector.
So what was the stumbling point with Newton's gravity?
Mass doesn't attract mass. Mass doesn't attract mass.
Yeah, but yeah, all right. So they've realised that then.
Well,
that's why they altered it.
You're giving a nice segue to the guy who said Cavendish earlier.
I've not heard balls in a shed for a long time.
Yeah, I smiled at that one too. It's been a while.
Well, that is the assertion that mass is being demonstrated as attracting mass. So that the torsion bar twist that you're measuring is as a result of those two sets of balls moving towards one another, i.e. they're being attracted to one another. That is very much claimed to be a demonstration of mass attracting mass. That's what Cavendish is. However, what you're observing is happening in the apparatus as opposed to being studied as a result of seeing it happen in nature. So there's no natural phenomena. It's being conjured within the apparatus. So to say mass attracts mass, that's an assertion of something occurring. But if you just decide that that's the case and then move forward to figure out why, well, hold on, does it actually happen? Does mass actually attract mass? Well, if you've got a claim to be enormous mass, that would be Earth as a sphere, will that attract the mass of a gas particle? Well, you would think so if mass attracts mass. But it doesn't. Gas moves in all vectors, not down at 9.8 meters per second squared. However, a solid moving through the medium of air will. But that's what we call weight. They just take weight and insert an introduction, then a removal of a force called gravity.
Well, the whole issue with mass attracting mass is that even if it was real, which it isn't, then it still wouldn't counteract the gas ability to expand in all directions every time, right?
Yeah.
Even how's that mass attracting mass going to keep that together? It's still going to expand in all directions despite.
Or to put it another way, the notion of mass attracting mass is a violation of the second law of thermodynamics. It's a reversal of entropy.
And if gas is leaving the Earth to start with, and mass was attracting mass, it would never leave the Earth, would it?
That's why they use it. Yeah, that's the full circle assumption, but it violates natural law. But yes, what you're describing as a negative, they actually spin into the positive claim based on you being pre-programmed from a very early age to understand or think of mass attracting mass.
With 5 minutes left, one question left. Any evidence you can have a curved baseline while acquiring an elevation angle?
No, and they'll need that to measure a angle to get an R value to claim the Earth's a sphere. Sphere Earth is based on those angle measurements from a flat plane.
What's
I
an
keep
angle
asking
again?
him to show me. I used to keep asking him to show me a curve baseline, and he say, "We don't expect a curve. We're not the ones mentioning a curve." I say, "Well, you're the ones who need the curve because you live on a curved Earth."
No, you've got the wrong attitude. I've got to whip this out of the panel and Discord. When someone says, we wouldn't expect to see Earth curve, we wouldn't expect the horizon to block boats and buildings, you don't say, yeah, you would, you're a globe believer, this is how you would expect to see it. Your correct response is, say it with me, welcome to flat Earth.
Welcome to flat Earth.
Welcome to flat Earth.
We wouldn't expect to see it curving. No, not you would expect to see it curving. No, yeah, that's right. We wouldn't expect to see it curving. We agree. Welcome to flat Earth. We did that. This has happened with Coriolis effect. They deny drift and say why we won't expect to see it. How something can leave a non-inertial reference frame and then continue to move with the non-inertial reference frame. So as you watch the drone take off the ground that's spinning, it just carries on moving in the air above the ground that's spinning without any effect to observe. Now you've then got two choices. Either correct the globe claimant on their misapprehension of what the globe claims. No, Mr. Glober, you should be saying Earth turns underneath the drone. Why are you telling them what they should be claiming? Just welcome them to non-rotating Earth. So you're saying there's no Coriolis to see. Earth's not turning under the drone for us to see 15 degrees an hour. Thanks, Bob. All right. Well, welcome to non-rotating Earth. Glad to know you're not claiming there's Coriolis drift then. Go on.
Sorry. The lack of evidence that it's happening is the proof that it's happening. Come on.
Yeah, that's the point, isn't it? Well, the fact that I can explain away why we're not seeing Coriolis drift is proof we spin, because I said we spin at the beginning of explaining away why we don't see it. No, we just don't see Coriolis effect. We're supposed to if we're turning, according to your claim of a globe Earth. There's claimed to be Coriolis effect. There isn't. But no, elevation angle 10th, no. Curve baseline, no.
No, yeah. And to Chocolate's question, it takes two lines, obviously straight, meeting at a vertex, a common point, to get an angle.
Two straight lines? Well, that's weird because you asked about a curved baseline. That's pretty different, right? Curve doesn't mean straight, right?
That's why they can't get an angle from a curved baseline.
Thanks.
Well, that concludes the housekeeping questions.
Perfect. Any last remarks? No. With that, I'm going to say, if you are watching this on either Nathan Oakley 1980 or Nathan Oakley premiering streams, then stay tuned, as there will be an after show to follow. Unfortunately, if you are watching this live, this is where we bid you farewell. So a huge, massive, enormous thank you to all of you who smashed the thanks button, smashed the super chat, liked, commented, shared, subscribed, joined as a member, and all that good stuff. Once again, stay tuned if you're watching on either premiering stream. I've been Nathan Oakley, and I will see you all in the next video.
What a lovely day!
Condolences.
Sorry to hear that, John.
Bit of audio chaos going on, I see.
No, not really. John just on the road wanting to know if we can hear him, and we said yeah. So
Any ballers out there?
I don't think we ever need ballers again. I mean, we got Nathan the baller. That's
The
like
devastating baller, Nathan Oakley.
he is like the big boulder in Indiana Jones, the first movie. This is terrifying.
That's funny.
well, he did get on a bit of a roll.
You know, the other day when he did that, I went in chat and I see Owen say, Nathan is scary as a baller.
Put that in the
just
edit.
started laughing.
But members have seen this already, but I'll release it over the weekend. But I've turned that into a trimmed out clip, and I think it starts with Arwin saying that.
Yeah, but when you read it in chat, it's a little more powerful.
But when you know their argument better than they do, then it's a commanding position, and Nathan has both sides covered. So
we all
Right.
do. It's not just me.
What
Any of us
argument?
could do that. Any of us could do that if you put your mind to it.
But it's
Well,
also
I-
because Nathan is just as ruthless as he is a flat earther when he's a baller. Like when I do ball win, I'm really kind of tame, right? I'm really nice and tame. Nathan doesn't seem to be very nice and tame as a baller. He's really scary.
no, he's saying the same things, but he's saying it with a connotation, speaking a little faster, trying to rush through it to kind of give the impression that he knows what he's talking about, but he knows he's using the rhetoric, so he does it that way.
Yeah, I know I'm
The
bullshitting.
only thing though, I had a kind of a laugh at though was the other day when he was doing that, and I forget who it was.
Matthias.
Something, right? And when Nathan was claiming that it was science, and Matthias asked him, "Well, how would you manipulate the rotation of the Earth?" And Nathan said, "I can't manipulate that." He was actually honest with it. I think a true baller would have found some type of way to say some nonsense that would have worked. That would have made that work out.
Yeah, but the
But
job was
because-
done.
Yeah, that's what
Yeah,
Arwin does, and
Only
it
because
really
they're
bugs
sloppy.
me.
And
If
Nathan isn't.
it's an educational tool. Now, while I appreciate that there's going to be lying scum that will say, you don't need to have an independent variable, right? That could have been a response I used. Would you agree?
Yes.
Right.
Yeah.
Why didn't I? Well, because when you get to the point that the conclusion is actually there, it is a genuine win, you want to labour that point so that you at least instill the confidence in the person listening to know that that is the win. But if I lie and be Arwin, their reasoning to do that
Hey.
is so that the conclusion is lost. Well, by rumpusing the point, or it's like, well, it stops being an effective teaching tool then, doesn't it?
No, I completely agree. I'm just saying I found it funny because that's the part where I would have been like, wow, baller would have just kept going with the nonsense. But because you're being honest, even if you're being a baller, that's not going to happen. So I understood completely.
That's why I said the job was done.
Right, but he didn't necessarily need to defend it, right? He was just honest. It didn't necessarily disprove everything else, right? Because that's how a baller really should be operating, just with whatever appears to be there in people's consciousness in the moment. And he was just honest. You can be honest and they'll still not catch on.
Yeah,
It works great.
I'm not trying to represent anti-flat earthers when I do that.
Yes, you are.
No, I'm not. I'm being as...
Yes,
okay, I am. You're right. In my attitude, I'm representative of anti-flat earthers. But would any anti-flat earther say, yes, I'm going to appeal to consensus? That's not the way they would phrase it. Yes, I'm going to beg the question, my independent variable, assumptions come inside. They wouldn't phrase it the way I phrased it, to lead my compadre, my brethren, my flat earth buddy into the understanding that he's got to attack certain points. Well, that's not what an anti-flat earther would do. What an anti-flat earther would do was try and hide those leading points as much as possible and make them as subtle as possible. And rumpus when you try and actually tie them down to what they're saying. So you're begging the question of Earth turning beneath the stars then. That you'd have to bring that out of them. They wouldn't just declare it like I did. But like I say, it's a teaching tool.
Well, you
I
had to be.
agree. No, you're not. That's why I don't call you an anti-flat earther. That's why I call you a baller, because you do it right. Anti-flat earthers only spend time confusing you and radiating fake confidence about themselves without actually providing information. That's what they do. They don't inform you. They just fuzzy things up.
Yeah, circle jerk.
Yeah, but you had to be. You had to be privy to the conversation before. He was arguing walls, that Earth didn't have no walls in the pre-show.
Yeah, he's
his
fighting
argument.
against the false equivalence of them saying Earth and atmosphere move as one. That's they, anti-flat earthers, after they're denied that Earth turns beneath to cause Coriolis effect. And when they're justifying why they don't see the effect, they have Earth and atmosphere in a contained system moving as one, which is the only way that could be described. And he's saying, well, that's false equivalence because they've got an open system. Yes, that is true. But by then you're arguing about why we don't see the effect the globe claims we will see.
Right, which is already begging the question that Earth has an axis to begin with.
Exactly.
I would disagree with one thing only, that a baller wouldn't say. When you said they wouldn't say that they're appealing to consensus, they might not put it that way, but they appeal to consensus all the time.
And they beg the question.
That's almost standard.
Yeah. Everything I did was standard. They would appeal to science as being proof of their claim. They would appeal to consensus and authority, and they would beg the question. But they just wouldn't say, yes, I'm going to assume that Earth is the cause of this effect. They wouldn't say it in those terms. They would do it, absolutely. That's why I didn't feel justified and agreed with Arwin when he said you're being like a baller. Because a baller would just beg the question. Yeah, and even when he said, so you're just assuming it, I can remember having to, how'd you face that down? I faced it down. You've watched me face it down. When you go, so you're just begging the question, and they go, yeah? What of it? Well, that's a logical fallacy. No, I know Earth turns.
I love it when they do that.
Yeah. Hello, everyone.
Hey, Brian. Good to have you.
Hey, Nathan. Hey, everyone. Just on that point.
Top of the morning.
Top of the morning. Just on the point that you were talking about there, where you conceded that you can't vary and manipulate Earth turn. As a baller, I would say, I would have said there, I know it wasn't for the teaching, it wasn't a good teaching to you by doing that other than what you did, but what a baller probably would have said is, when you ask that, well, we know that from the north-south flights in the Coriolis force, blah, 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 and gone off onto some other nonsense. That's what they would have said.
Okay, in which case you have to know what Coriolis is and know that you can only observe it, not actual drift, as you're turning. So it's got to be your eyeballs watching something not actually curve as you turn beneath. That's the only way to have described the Coriolis effect. So as soon as they start saying, well, you've got these flights that retain the angular... No, that's the projectile. The effect is describing something not happening. So, yeah, you can describe a ball travelling in a straight path and you turning beneath it on a roundabout, and the effect that the globe claims to have is Coriolis, which is you observing the ball seem to curve. So if it's translatable to turning Earth, it's you on a turning Earth watching things seem to curve that don't really. Well, that's nothing to do with the projectile actually curving or actually correcting for curve.
Yeah, but what's happened there then is we're talking about the Coriolis effect, and we're after moving away from the independent variable that I'm supposed to be manipulating to show that proves the supposed effect that we don't see ever of Earth rotation, that we don't experience.
Gotcha. So you're saying you have to lead them a little bit and say, well, is there any science to prove this? Because I was saying to the guy earlier, you can't just, I think it was Matthias, you can't just ask if they've got science for it. But by the same token, what evidence have you got for axial rotation would hopefully lead to the point, like it did in this example also, a guy blurts out, Cavendish, or gyroscopes. You know, you hope that they'll assert that and assert it as being scientific validity. Otherwise, you can't pull it apart on its lack of independent variable because they haven't said it's science.
Yeah, it's just me bringing up the Coriolis, what they call the Coriolis force, is the whole point of me doing it though is getting away from an independent and dependent variable. So I'm getting away from that as much as possible. And now I have you talking about the Coriolis effect, which is better for me than having to come up with an independent variable.
I see. I finally clicked after the pennies dropped. So you're saying the whole point when you point out that there is no naturally observed phenomena and presumed cause being varied, i.e. science, the easiest way to get around that problem is to take the conversation as far away from the cause being varied as possible and talk about something else. So I have to focus now on, well, you're talking about the projectile. Yeah, but I'm not talking about the varying of an independent variable now, am I? That's your magic trick, right, Brian?
Exactly.
Can you see my image in the text, Nathan?
No.
It's chemtrails. Would they not appear curved to us if we were rotated?
They do, but only as a result of perspective. So when we're talking about the flat sky and how if you're looking, I've got a diagram of this on previous shows, where you're under a bridge, right? If you are literally underneath a big suspension bridge in a boat and you look from left to right, from your vantage point, if it's a big enough bridge, one end meets the horizon, yeah? So you turn to your left. Your head would turn towards your shoulder with your chin on your shoulder, if you like, looking at the end of the bridge. Then, as you move your head, you'd have to elevate your angle of view to see the top of it over the top of you. And then when you move to the right, you put your head back down on your chin to see the end of the bridge. Well, that's a curved motion that your head's taken. Now, the bridge is perfectly flat in this example. It's just a perspective view of you with something appearing to curve over you because it's further away at one point than another. Well, the same is also applicable to the stars. When they move and you measure the angle, it's assumed to be a flat sky. Can't work any other way. I've forgotten your question now. What was it you were saying?
I think what he's saying is not a vertical curve the way you're describing it, from horizon above your head and then back to the horizon again. He's talking about chemtrails, and they are in a straight line because the plane is flying straight.
But they're not.
It's not deviating.
But they're not. I get up early every day because of the kids, right? So I end up going, and it's nice in the morning. The sun comes up and you get the long shadows and the kids love playing in them. Anyway, when they look up and ask me, why are they doing that in the planes? I have to be careful about what I say. I don't want to give them a load of nonsense I don't really know about and can't verify. I have to kind of say, I don't know. I don't know why they're spraying that crap in the sky. But they are, that's what they're doing. But what I observe in them is them appearing curved to me. I always think about it, how I know they've travelled in a straight line, but it doesn't appear that way, does it?
I think it does. I mean, I know what you're saying. From horizon to noon or straight up and then back to horizon, yes, the arc of the sky, because of our eyes, the way they work, I agree with that. But I think his question is a little different than that. Maybe he could ask it again.
He doesn't need to. I know his question. He's saying, shouldn't we have the deflection, the not actual deflection, observed in the formation they leave behind them, right? As you turn beneath them, even after they've been delivered, what you would see is the apparent deflection because they're stationary and you're moving. Well, no, we don't see any deflection in those streams of clouds, whatever they may be, coming out the back of aeroplanes in the mornings. I don't see that. Now, I do see an apparent curve as a result of the perspective view I get when it comes from horizon to horizon. But that isn't not actual deflection at 15 degrees an hour, which is what you would expect if they have the effect they say Earth has, which is Coriolis deflection. It doesn't. So I am being pedantic, but not pedantic, hyper-specific. Hope that answers your question, Brian.
I'm just going on the Earth turning under the football. I thought you would have the same effect with the Earth turning under the plane, and the trail would be, to us, look curved.
Yes, exactly. It would if we were turning underneath. The Earth would be a non-inertial turning reference frame, and the degree of drift that you observed, not actually, the plane can travel in a straight line, but what you would see is a motion that appeared curved. Not because it is curved, but because you're turning beneath something that's travelled in a straight path. So the curve that you would see, not actual curve, would be Coriolis deflection. Well, do we see that? No, we don't. Why not? Because we're not turning. if we were, we'd see that effect.
How
Every
crazy
image
is
I
it to
can
even
find of
think
them,
that, though?
they all look perfectly linear lines. There's no sort of curvature been detected of the Earth turning under the plane.
No, that's what they say we'll see. Coriolis deflection. We don't see it. If we did, it would mean we were turning beneath planes, and if Earth's turning beneath planes, it's shortening their flight times when travelling west.
Think about how crazy that is, though. Neil deGrasse is telling you that the Earth is rotating underneath a football, but a plane flying over that very stadium at the very same time, the Earth's not rotating underneath that? Does that make any sense to any normie person?
No.
That's insane.
But it's not meant to make sense, is it? I mean, it's so convoluted and confusing. Nope. The whole point of us talking about it right now is because we don't want to fall into the trap of telling globe Earth believers what they should believe in, because they're denying their own claim in the first instance. When Simon Dunn comes along and says you and your reference frames are ruined, it's a way of him projecting the failure of Earth to demonstrate itself to have two reference frames. And us pointing out that it doesn't, there's no drift, results in him denying his own claim in the first instance. But putting them on me is cause of a good laugh, and whatever it is, 3 or 4 years later, we're still talking about it. Because it is them. It's an example of them realising they haven't got their claim to prove. They haven't got any drift to show. So let's show why we don't have drift instead. And blame you for it. Here you go. You're claiming that Earth should turn underneath planes, aren't you? No, I'm not. That's Coriolis effect. We just don't see it. You're mistaking me pointing out the failure of a globe claim as my claim. How hilarious, how stupid, how ignorant of Coriolis Simon Dunn must be to make such a glaring error.
They can't help themselves because, as earlier commenting, when you know their argument better than they do, you're in position of power because you have the knowledge. And the minute they deny that claim, you say, but that's your claim. That's what's supposed to happen based on living on a globe that's supposedly spinning and doing all the things you say it's supposed to be doing. You're denying your own claim to win an argument?
Right. Or not understanding the claim and resulting in me suggesting that a pilot should lose his job. I mean, obviously, me saying that should, if you're a globe believer, result in Wolfie contacting his solicitor and having me shut down, cease and desist. He didn't. He gave me money after me pointing out that Wolfie should be sacked because he doesn't understand that deflection observed from the ground in an aeroplane, that's Coriolis effect, isn't something you can correct for in an aeroplane because it's not actually happening. But he was telling Anthony all about how his plane corrects for drift, making him an idiot, making him dangerous in the air, making him want to give me money for pointing out how stupid he is and how much he should be fired. Thanks for the cash, by the way. Really appreciate it, Wolfie. I got a new graphics card with that money.
That is a funny response from an anti-flat earther or baller or a combination of both.
Well, thoughtco.com, they call it an illusion. So does he have an illusion button in the plane? Quick, account for illusions. Right next to the center of the Earth mode button, right there.
Center of the Earth mode button, the illusion button. They got so many buttons that actually they should be putting these buttons on there so they can really drive home to the pilots the Earth is really turning.
Quick, hit we would expect to see whatever, insert whatever claim button.
Oh my gosh.
That's literally all their claims have come down to that now. You would expect to see all the claims that we make that we expect to see. You gotta love this shit, man. Sad.
Courageous. Wolfie claimed to me in a comment on YouTube that he doesn't refer to horizontal when flying. Every attitude indicator, 0 on the attitude indicator, is horizontal. The attitude indicator indicates the degrees above horizontal or below horizontal of the nose of the airplane. That's what he said. I don't refer to horizontal when I'm flying.
I remember that one. I remember that, yeah. Brian. That was sad.
I have the comment there somewhere.
He's going to have a shot one day.
But did you just say I have to comment, Brian?
I have the comment somewhere. I have it on my phone or on my computer.
Oh, I have the comment.
Well, who's got the other half? If he's got half of it.
No, I have. I thought he said he kind of did. He said I have to comment, but it's I have the, not to. I just mistook one word. I thought he was wanting to say something. Don't worry about it.
No, it's good. I'm glad it happened because this is why words mean things, and Socratic method is good.
I came on the show originally after Wolfie said that, and I stated that Wolfie. I originally stated, I think I showed the comment or referred to the comment, but I stated that Wolfie claimed that horizontal didn't exist. Right now, I strawmanned him on purpose because he claimed that he didn't refer to horizontal when flying. Now, if you're flying several thousand miles in an airplane and you're saying you're not referring to horizontal at all, to you then, as far as anyone is concerned, a passenger or anyone else, as far as they're concerned, as far as you're concerned, as the pilot, horizontal doesn't exist. If you're not referring to it, then it doesn't exist. You know, and he's been livid ever since I did that. He has these trolls constantly hassling me about Wolfie didn't actually say that. No, all this rubbish. It's like, why doesn't Wolfie just address what he did say then? Because the only way to get him to address what he does say is to strawman him with what he didn't actually say, but was employed. You know, how else could you take it? As a passenger, if you heard that the pilot doesn't refer to horizontal, you have to start going, what's going on here? Do you know what I mean?
Yeah.
You'd have to start thinking, does he think horizontal doesn't exist? You know, so when is he going to address his original comment? He's a big hotshot military and commercial pilot. When is he going to address his stupid comment? He'll never get the data he's supposed to get to prove his claims, 6-year claims. He never comes up with any of that. Never does any of these things. So the least he could give us, the least he could give us is the addressing of that statement. You know, the addressing of his comment. He does not refer to horizontal when he flies. Give us that much.
Yeah, hold on. I just want to so that's rounded out because I know you're asking him to answer, but by the same token, what's the relevance, right? So when you talk about the wings and their position and how many degrees they are, I'm trying not to say the words that I want you to say, Brian, in case you can't tell. So that would be an angle measurement, right?
Yeah, exactly. The nose and the wings, anything above 0 is above horizontal.
0? What's 0? That's where I was going.
0 is horizontal.
So when he's talking about the angle of his wings, he's talking about it with reference to horizontal then?
Well, the wings... See, this is the thing. You have to state the nose because the wings is to do with lift. And technically...
My bad. It's a bad example. I get it. It's going over a curved surface to create lift, and it's presented in such a manner that you're not going to talk about that angle. You're just going to draw a line down the plane and talk about it with reference to the nose. Okay, fine. I was just... my ignorance in terms of flight is not relevant to your point, but carry on. There's no disclaimer needed now.
No. He'll just try and split hairs as much as possible there, and talk about how he can fly upside down and do other things. And you know what I mean? He want to go into the lift formulas and all this other nonsense, and just bamboozle you with as much nonsense as possible instead of addressing the point. So when you address the nose, the attitude indicator is addressing basically the fuselage, the nose of the airplane.
Oh, he's trying to show off.
It's the altimeter on the plane, though, isn't it, that determines the height, and it works out from a fixed level, which a level is a horizontal plane.
Yeah, they have to set their Q&E.
But the actual best argument against pilots is not even, well, it's the attitude indicator, but it's actually the chord line of the wings. Because the chord line of the wings have to be above horizontal for that plane to hold positive lift. It can't be below horizontal. They must be above horizontal. And that's why the nose of the airplane is always above horizontal. Because it's like when you put your hand out the window of a moving car. When you tip it down slightly, it'll go straight down. When you tip it up a bit, it'll lift up. So they have to have it. They have to have the right amount of degrees above horizontal. For the chord line of the wings, has to be the right amount of degrees above horizontal, as per their flying, their airspeed, for them to hold positive lift. There is one wing that can hold positive lift up to about 2 degrees below horizontal. You know, up to a point. But the problem with that is officially anything below horizontal is officially a descent in aviation. So, you know, the chord line of the wings refers to the lift effect. And that has to be above horizontal for the plane to fly.
Brian, how many times have you watched videos of pilots referencing the horizon to get their bearing because instruments aren't working? How many videos have you seen on that?
Yeah, I've seen some stuff on that. Yeah, I've seen the thing about the horizon though is the horizon is well, we go back into the black swan argument then if they start claiming it's the leading edge of a ball.
No, forget all that stuff. I'm talking about a pilot who lacks instrumentation because there's a glitch. I've seen videos where they say, okay, now look over your left wing, line it up with the horizon, look over your right wing. I mean, they're talking about it horizontal. What's this guy Wolfie talking about?
Yeah, look, what Wolfie wants to do is he wants to have an argument with someone about flight charts, the planning of flight charts, you know, without realizing where the flight charts came from or come from. He doesn't understand these flight charts, or he doesn't understand the origins of them or what even he's claiming with them. But that's a separate issue.
Can I make a guess? Hold on.
Sorry?
Don't brush past that. Can I make a guess? Is it Earth-centered, Earth-fixed?
Yes, well, that would be his GPS data. Would be that. But the flight planning, or like when he plans a flight, he thinks he's using a globe to do that. He doesn't understand. I'm not going to go into details now on purpose, but because I'm not going to go into them right now. But he thinks he's referencing a globe. He doesn't understand what he's doing.
That means Brian's got something up his sleeve.
I'll make it very simple. I'll make it very simple. Right. He is using what he calls great circle routes. Right. Great circle routes avoid the Southern Pacific completely. Right. They have to. Right. They have if you're using great circle routes for flights, if you're going from south to north, south to south. So if you're going South America to somewhere else south, like Australia or somewhere, you're going to be going north and then south with great circle routes. You know what I mean? So you'll never go just across the South Pacific or South Atlantic. You don't do that at all. Planes never fly that route. They only go what they call great circle routes, which is all north-south as much as possible. So, they won't have to go north-south if they're going from Europe to America. They'll be able to go over, let's say, Greenland and other places, but they will be going as much. They will be, it depends on how far south both places are. You know, if they're going to Southern California from Spain, they might go north and then south on a globe, but in reality they're just taking a straight line. But they're keeping close. They're going to keep it, if they can, they'll be keeping close to land, you know, as much as possible for safety. But the point is that it's a begging the question fallacy. Great circle routes. That's all it is. What's a great circle route on a map, Nathan?
Just a line.
Exactly, a straight line.
Brian in Discord wanted to say something. Go ahead, Brian.
Sorry, mate. I was just going to chime in about the wing incident angle is a line drawn down the center of the fuselage, and then the wing is put at 4 or 5 degrees above that line. So the angle of attack is can have the nose down, but the wing will still fly because wing in relationship to the airflow is still in a positive lift situation.
Right. So you're saying if you draw a line down the plane, the line might be pointing slightly down below the horizon, but so long as the lift is achieved at the wing's angle that it's placed while in that configuration, then it's still got positive lift, so it makes no difference.
Well, no. The only plane that flies, one second, Brian. The only plane that flies, right, that can fly, not that it does fly, it can fly with its nose slightly down or at horizontal, while still holding positive lift, is the B-52 bomber. Right, that's the only plane that does that, right? And it's designed that way so it can see, so the pilots can see down below them better, so for when they're dropping bombs and whatever else and whatever they're doing. But the thing about it is that the chord line of the wings and lift, that is all connected to the plane, right? So if they have to be up above horizontal, the nose of the plane has to be up above horizontal. You see, the reason the reason the plane takes off, they like to talk about the lift effect and this, that, and everything. There's two parts of the lift effect. It's not just that you're pulling back or pushing down the elevators at the back. It's the thrust. It's the thrust. The thrust that the plane has going down the runway, right, is what causes the airflow to go past the wings, right, at enough of a velocity. And once the wings are at the right angle, then it will lift. So my argument is always, just for Brian, my argument is always commercial airliners, because there's different fighter jets that can do different things and blah, 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 but none of them account for curvature or rotation or any of this stuff. Commercial airliners fly with an average of nose up pitch of 3 to 5 degrees all the time. That's the only. They fly the longest distances. They're the only ones that matter.
It's a balance between lift and drag. The more lift they get, the more drag they get. So they trim it out to have the lift they need without as little as drag as possible.
Yeah, but the nose. See, the only time that the nose can be below, the only time they can, if you have a cambered wing, I'm going to lay it out right more specifically. What you said earlier was that the nose can be below horizontal, but the wings can still be holding positive lift. Right, but as long as the nose is below horizontal, that plane is in a descent. From horizontal and below horizontal, anywhere below horizontal is officially a descent. The cambered wing, right, can hold positive lift. There will be a certain amount of positive lift up to 5 degrees below horizontal, but it will lose the 50-50 balance after 2 degrees. It'll be 60 positive, 40 negative at 2 degrees, right? And once it gets to 3 degrees, it'll go to 60 negative and 40 positive. So all it does is the cambered wing will help slow down a descent, but it doesn't matter. Once that nose is below zero, below horizontal, it's in a descent. So the argument then about the wing and the lift formula, or the lift with the chord line at that point, doesn't matter, because the plane is in a descent. The plane, for a plane to fly in a straight line, it has to have the nose slightly up. It has to. And that's why on every commercial flight, right, they always have the nose 3 to 5 degrees above horizontal for a cruising altitude all the time. They might drop in altitude, but that'll be a drop in thrust. And if they have to do that, they lift the nose slightly if they have to. But they will not be, majority of the time, the odd time they do it, but the majority of the time they never just tip the nose below horizontal and fly down to change in altitude. And if altitude change, will be very little.
Yeah, when I looked into it, because it's important to understand out, certainly how the commercial jets I was going on do operate. That's the exact truth. They never ever rock forward. All they ever do is increase that angle upon descent and takeoff. Because obviously, as you're descending, you want to keep your upward thrust, as Brian was saying, but you really want to be slowing down, don't you? Because you're going to be touching down. So the way to do that is to balance it, which is why you really lift up at takeoff, because you've not got as much speed, therefore upward thrust, so you generate more by angle of raising the angle of attack. But what never happens, these things would fall apart if they tried to turn over forwards. They're not built to fly like that. They're built to stay very, very flat and stable. And the way in which you move the aircraft is, like you say, with speed and just basically speed in the ailerons, isn't it? So totally agree that you might get the odd one or the odd funky design, like some of the jets, to stop them lifting. Because sometimes when you're going so fast and low down, they'll flip. You know what I mean? So they have to have angled noses. Concorde had one, which is just, again, to cope with the extra speed and to stop the front raising too much.
Got some slides in Master B, Nathan, and Brian and Adam can comment on it.
Hold on one sec before you do. I was just going to ask. Now, when you're talking about the attitude of the plane, like why were we discussing that? Is that because he's denying that horizontal has to do with attitude?
Well, Wolfie stated to me in a comment, I'm going to try to give him a verbatim his exact words, is that he does not refer to horizontal when he's flying. Now, we all know 0 on the attitude indicator is horizontal. So what he just said there was a total lie, because that would mean he doesn't refer to his attitude indicator.
I mean, I can understand as a baller you're saying something like that, but as a pilot, you're really going to say you don't refer to horizontal, man? Like, what a joke.
Yeah, it's a poor show, you know, it's a very poor show.
All pilots are trained the same and have to presume the same. It doesn't alter between a different personality. This Wolfie, I mean, who does he fly for? Because I won't be getting on his plane.
I was just gonna say, yeah. Does he have any actual people that went on him with the plane?
Well, you can't hit Brian. You can't even pull out the beverage cart to serve drinks if you're not flying horizontal.
Temp, I was just gonna say, like, the next time I get on the plane and the flight attendant brings me my nice hot coffee and it's sitting on my tray table, completely level, I'm gonna say, thank God, horizontal doesn't exist. Like, what?
Well, the truth is that if you look at the trolleys, and the direction they're moved, they have locks on the wheels, and they always, when they stop them at Uroil, they always lock the wheel. They have to, because they're at an incline. The nose is always at an incline. So if you're walking from the back of the plane to the front of the plane, you will feel like you're walking slightly uphill. And obviously the opposite then, if you're going from the front to the back, you feel like you're going slightly down, because it's always at an incline. So those trolleys always have the lock put on them, because they're not exactly at horizontal. They're actually slightly inclined. But
Brian,
as anyone knows...
I can understand what he's saying, Brian, because I've done quite a bit of flying with my partner's got a Cessna, and they would pick a point on the screen to just get level with the horizon, which is about at the right pitch the nose needs to be. You understand what I'm saying? So it'd be a visual thing. That's what my partner does anyway. He will literally, instead of keep looking at that, see which way the nose is pointing, he will literally sort of set a sight up on his screen, on the windscreen in front of him, to the horizon, which would give him a visual heads up as to which way the nose was pointing.
Yeah, I understand that, but he still has to. He's a commercial pilot flying a commercial plane with possibly cargo, passengers, whatever. You have no choice but to refer to your attitude indicator. And 0 is what you're saying is a way of visually doing it, and I understand that. So you're keeping a visual point in reference to the horizon, and yeah, that's fine. And I would say that's a lot easier and easier to do with a Cessna than it is with a commercial jet, because obviously a commercial jet, you're likely to have passengers and other things. So you're going to have to be more precise. But it would work the same way. But the thing about it is that you look at autopilot. What does autopilot do? Does autopilot hold the plane at a couple of degrees above zero? Yeah.
Yes.
It has to.
I doubt, after they've took off and set their course, I doubt if they put any inputs in whatsoever until they're ready to land. Drones will do it. I can send my drone from here a 5-mile trip round and it will look after itself all the way, easily. So you've got to say they've got this technology in planes.
All this communication is what's my word, gyroscope based.
Yeah, exactly.
And before anything happens, so that they can have surety in these devices, they have to sit on the flat, level ground and calibrate their gyroscopes. Once they do that, then off they go.
Right, and then after that, they got...
At no point in the journey do those gyroscopes accommodate for or adjust for cumulative curvature of the ground falling away.
On the apron where they load them up is perfectly level, and that's where they call it caging the gyro, which manually supports the gimbals, and then spin the gyro up and then release it. So it is caged to that level piece of ground that it sits on while you lot are getting on it.
Right. A gyroscope is really all you need for an autopilot. It will tell you exactly how to keep level, how to keep steady, how to go in the exact same direction, even with unexpected external things that might change you slightly, right? All you need is a gyroscope, because that tells you exactly where you're at and what your angle is in it all. And then, something to basically push it on that level every time, back automatically, something electronic probably, and that's it. Keep going forward.
Well, if you, sorry, 1 second, Ted. If you fly from London to Los Angeles, it's an 11-hour flight. If you do the maths for a globe, you should end up 78 degrees below horizontal from your starting point of horizontal, which would start at cruising altitude. You should, at that point, never be able to fly with the nose above horizontal. You should have an accumulated below horizontal pitch all the way from London to Los Angeles, which accumulates, if I remember correctly, at 78 degrees below horizontal. That's on a globe. Sorry, go on, Ted.
No, I was going to say the rebuttal from his followers white knighting for him. Are they saying he didn't say what you think he said, or whether, or isn't that? I mean, I'd like to hear what they're saying that you thought he said versus what they're trying to say.
Oh, they're writing me a text telling me this was his exact quote. They have no idea what he said. This was the exact quote, and they're just making up quotes for him, and he's just accepting this nonsense. Now, I don't care, because it's only him and his idiot cronies. But, like, this is how pathetic it is. He will not address what he actually said. He keeps on telling me, you go and get the actual quote, blah, blah, blah. I said, no, address what you say. You know, because he has two choices. He either can, tell me something different from what he said that's the same kind of thing as what he said, and it'll be just as bad, right? Or he can tell me he does refer to horizontal, which he doesn't want to admit.
Well, this is what I'm saying. So this whole situation you're in is a win-win for our side, and especially when you're holding him to it, because he's saying he doesn't refer to horizontal, but everyone knows he's got to. But if he says he does, then he's going to be saying, well, then the Earth is not curved. So, I mean, it's a win either way.
Excuse me. If horizontal doesn't exist, what's an incline? What's a decline?
But there you go. You're strong on them now, chocolate.
I'm just saying. if you're not referring to that, then how do you know what your plane's doing, whether it's inclining or declining? How do you know if you don't have a horizontal to base that off of? It's a little weird.
Well, that's the question he won't deal with. So he wants to have his cronies.
Because it's so basic common sense that you can't deal with it. It's like, that's terrible, man. You're a grown-ass pilot.
Yeah, I mean, he'd rather have his cronies send me text.
Sorry, Roy. Go ahead.
I'm just saying, if the plane is flying round the globe, then the sextant doesn't work.
But the sextant works, so the plane isn't flying around the globe.
What globe?
Exactly.
Well, one deck, Wolfie has had 6 years to produce the data, just the pitch data. That's all that's needed. We don't have to see the thrust data, just the pitch data that supports his claim. 6 years, heading for 7 deck next year. 6
Did you say?
years.
Did you say we don't trust the data?
No. No, trust data. We don't need to see the trust data. Well, we do need the pitch data. But no. And there's another thing, pitch data, it's very difficult to get. I've been trying to get it. It's very difficult to get. Why is something as simple as the pitch data from 10 commercial flights, why is that such a big deal? What would that prove or show to the world? Tell you what, it wouldn't show and prove that we're on a globe. Wouldn't show any of that.
You think he just kind of misspoke in the heat of a discussion and made a clumsy statement that he's just having a hard time reconciling?
No, because he made a clumsy statement, right? But it's not, I mean, yeah, you're kind of right. But the questions was about horizontal, because the only place he has to go, as soon as he admits horizontal is used in flying, and he refers to it, as soon as that happens, then right, his only place to go then is that he's referring to a local horizontal. That's his only avenue. And then okay, well, your pitch data will support this. You know, which is the very thing he won't get because he's a liar.
I saw this in one other place when I was researching the sextant, and it's this one guy who has a video, and he's trying to explain the horizon and level and the horizontal. I'll have to get it. So when it comes to that part, he wants to say straight, level, flat, but he can't get himself to say it. So he's stumbling for his words, and then he's getting his hands into it, and he's kind of like doing a motion of, you know, flat or horizontal, and it's an epic thing. I'll see if I can find it and then give the timestamp for it. It's almost exactly like this, except a guy with a sextant's running into the problem because he doesn't want to say flat.
Well, yeah, I mean, like what Brian said earlier about how his partner will refer to the horizon. See, a lot of the time pilots will say that. Like Wolfie said that to me, but that, like Brian is right from a common sense point of view. Yeah, it's just there's a flying just horizontal, but they can mentally beg the question that horizon is the leading edge of a ball. So that's why, as an argument, it was always only a 50-50 argument. We could say, well, that's horizontal. And they say, no, it's the leading edge of a ball. And then we're into a black swan argument. But the thing about it is that that's why I always refer to the horizontal and the pitch angle and the attitude indicator and the chord line of the wings for lift. I always refer to them things, especially the chord line, because there's no way around it. They can't deny that. So that's why Wolfie is saying things like, well, I don't refer to horizontal when I'm flying, you know, like a complete idiot.
I bet he's not a pilot. I bet he just serves drinks in a dress or something.
Oh, he's like Wolfie. I know he is a pilot. From what I've seen, he's definitely a pilot, and he could be. I think because I did see photos of him from his military days a photo of him in his military days when he was younger, And like, he could be an absolutely excellent pilot. Like, don't get me wrong, he could be an absolutely ace pilot. But very likely he is. But that doesn't mean he's honest, even with himself.
It's kind of funny because while I worked at the airport, I had pilots almost shitting on their own profession. They would say, which doesn't happen very often because they're very cocky, but one or two of them would actually say, well, there's a lot that we got to know, but these things practically fly themselves. I mean, we don't really have to do much, to be honest.
I have two pilot that I spoke to. One's a friend and one's an acquaintance of a friend. And I asked him the question, do you fly with your nose up 1 or 2 degrees to keep level flight above the horizon? And they said, yeah. To the horizon. I mean, they just answered.
That sounds like an angle measurement. Oops.
Yeah, but the way you worded that there, Kent, is not good, because when you bring in the horizon into it, they can bring in their begging the question. I always refer to...
Well, you're talking to a baller. I'm just talking to a pilot who's describing something.
I know, but even for an ordinary everyday pilot, like, they're going to refer to the horizon. But the horizon for that person in a belief could be the leading edge of a ball. So I stick to horizontal. So you fly with the nose above horizontal to fly horizontal. Okay, that's the truth. They have to be able to move in a horizontal fashion. The plane has to have its nose above horizontal. So I avoid the horizon because the horizon is a separate argument, if you know what I mean. Now, I'm not saying you're going to have an argument with this pilot friend of yours. I'm just saying that like, the horizon to that person could be just the leading edge of a ball.
No, I gotcha.
Well, that would be weird considering the people that design these things take the Earth as flat and stationary when they do that. So,
Yeah, you must treat the Earth as flat and stationary when you're flying.
So the complete opposite of what they tell us it is. But yeah, that checks out.
Sure. No, but most ballers think that horizontal is like concentric circles of growing size. That seems to be the consensus on their side of the argument. It's nonsensical.
Is it because you can't really have horizontal on a ball? Maybe that's the problem. The word horizontal itself.
But see, that's why they try and refer to local horizontal. This is where they go to then local horizontal, and they can never give you. Yeah, well, the thing about it is that I went through it with one of the ballers. Had a whole weeks and weeks of a thing with one of them, and he was very. We were honest with each other. There was no viciousness or that in there, but we got to the point where he had to claim a local horizontal, but he couldn't give me an actual size to the local horizontal. You know what I mean? And there was other stuff as well. But it got to the point I thought it would get to, where, you know, they can't deny that you need horizontal. The horizontal has to be referred to all the time. So the best they can do is get to a point of saying local horizontal. Well, what's a local horizontal? How do you have a local horizontal? And how does that? The problem with the claim of a local horizontal, it doesn't work with what a plane actually does. Because a plane never treats horizontal as local. It's always a constant.
It's just funny to bring up the word local with a vehicle that's literally designed to not stay local.
The thing about it, how big is a local horizontal to a plane? When the average airliner is flying at like 550 miles an hour, that's 9 miles a minute. You know what I mean? Or something like that.
I mean, when I used to fly to New York to California, yeah, that's local.
So basically, you can kill them just by asking them for the definition of horizontal.
Pretty much.
As far as I'm concerned, airplanes are the greatest FE proof. Like, I know the Sextant is very strong and everything else, but for me, nothing beats the airplanes. Because there's 5 steps. parts of an airplane flight that has 5 different arguments.
Is Nathan still here?
Yeah, of course.
Hey, what's up, buddy?
Sky.
Just haven't heard you in a while. I was like, are we still live?
Yeah, we're still recording, but obviously if there's a conversation, I've got nothing to add to it. Why bother adding anything?
No, all good, man. Since we're not being burdened with globe proofsies,
yes.
How's your daughter, Clover?
Yes, Brian, he is.
And you're pretty well read now on the Sextant. Can we assume it's for plotting your position?
Yeah.
Would the vessel have to be as stationary as possible to get that position?
He's not responding, but yes, you're not going to be finding your horizontal, i.e. levelling the tool, if you're in a storm.
I was talking about speed, linear speed. Would you anchor up to do the observation?
You'd be within hand grenade range.
Hand grenade range?
It would depend on what you're doing.
I don't know. I don't know where he's going with this. Well, but from the time that you take your sextant reading to the time that you get the answer to where you at, are you going to move? Probably, yeah. Not by very much.
No. But what about at 17,500 miles an hour in the ISS?
I guess you would be. Yeah.
Makes it
I don't know if
bit...
they're taking any sextant readings up there, are they?
Yes.
Oh yeah. They showed a lot of pictures of them.
Really? In Narnia?
We showed John. We showed a video weeks ago with the NASA claim of how they navigated to the moon. They were using a sextant out the window on the way, mate. all you got to do. No, listen. This is NASA. All you got to do is line your sextant up with any part of the horizon, i.e., the leading edge of a ball, and take the angle off of that to your star. It's not my words.
Yeah.
No, you missed a bit. Obviously, given that there's a geometric limitation to your view in the flat universe, you can use that flat universe horizon when you go into the moon.
Yeah. And luminescent gerbils create dark matter.
Is that
so?
So?
I assume it's a manual process,
so?
Isn't it? You take a reading and then you have to do the maths on that reading. Take 2 more readings and you have to do there's no button to press and it tells you where you are, is there?
No,
so
but
the process of gaining your position is the same whether you're on a boat in the middle of the sea or whether you're on the ISS doing 17,500 miles an hour.
Yes, but the process, as you put it, is a flat Earth angle measurement, isn't it?
Yeah, but I mean, the time it would take you to do that process, you'll have shifted from your position that you took reading from at 17,500 miles an hour. So
a moving satellite using a sextant.
It's ridiculous. You can see it is just theatre. They do it for the theatre content.
Brian, what's the problem? I mean, they bought. I mean, they put the thing together at 17,500 miles per hour, so they could do anything.
Any video of that?
Video of them doing it.
Any video of that?
Yeah. No.
Yeah, I've seen some CGI cartoon one time.
Oh,
that was about it. You would think something like that would be heavily documented, right? You would think.
Yeah, presumably.
All the reels were doing that.
If it was documented, what would it prove? If they did have video of them putting this fake thing together in a fake place, what would that prove?
Nothing.
That it was fake.
But you would think it would give a little bit more credence, right? Not really, because the place they're building it doesn't exist in the first place. But yeah, you would think, just because this is how we know humans are. We build something, you videotape it, you document things. Oh wait, we're talking about the same guys that lost all the telemetry data. Ooh, my bad.
But it'd be like putting a gas lamp together in Narnia. If you had a satyr that was putting a gas lamp together in Narnia, would that make Narnia real?
Tapes those telemetry data were stored on was very, very expensive tape. And, you know, sometimes you just got to recycle stuff. NASA short of a few quid.
Thing is, it was the kind of dumb thing to do in the 80s, weren't it? Just grab any old tape because you like Match of the Day was on, so you wanted to record it. Didn't matter if it was your sister's and it had a copy of Pretty Woman on it. You needed to record.
The top 20 we used to record.
Right. There's enough fellas out there recording over their camcorder marriage ceremony. You can totally understand NASA doing the same thing, can't you?
Yeah. Quite plausible, that. Man's greatest ever achievement. And I'm sorry, we've taped over it.
Back then, they were doing it every other week, weren't they, going to the moon for a bit? And they probably thought, not be a problem, we're not going to lose this technology, so no one's going to worry about a couple of re-records.
Yeah, it's that same old way, right? You just think to yourself, next man will have backed this up. Obviously, it's a shared unit, shared computer.
I heard they found the golf ball from one of the moonshots.
Was that you, Tent? Bad day.
How far should that golf ball have gone?
I'm sorry. I was trying to find that clip. Was there a question asked?
Yeah, it was about golf. That's why the only reason you got his attention.
What's the question?
Somebody shanked a ball and one's been found on the moon, apparently.
Have you ever studied their form, actually?
The golf that they were playing on the moon.
Yeah, well, I was about to ask
one on Earth.
Have you ever studied their form?
The one. Yeah, it's just a gimmick. Yeah, I'm about to post a video on the timestamp. I'll be right back.
If the telemetry data...
150 yards on Earth, what would it be on the moon? 10 mile?
Narnia miles are very different.
If the telemetry data existed, would that make a difference to whether you believe they actually went?
Oh, absolutely. If you could show me, for example, how much fuel it would take in a calculation, that would go quite some distance to proving it happened to me.
Yup.
I couldn't believe Neil deGrasse Tyson when he said that.
You can't fake that info. I mean, you can't.
It actually would be easier to actually go there than to fake it.
Yeah,
that's
exactly.
literally a globe Earth argument that I've heard.
Well,
right, that's why.
I mean,
that's why Hollywood does all their space movies in actual space, because it's easier to go there than it is to fake it.
That's right.
But y'all are bugging. It of course it'd be easier to go to heaven than to fake it.
Yeah.
Well, wait. Actually, that's a bad analogy.
Well, it's the same as it's easier to go to Narnia and just see by measurable quantity how much gas goes into the gas lamp than it is to calculate it. I mean, that would cost a lot more money. So obviously Narnia is real. That's how we got the calculation. We went there and we got it. It was far easier than doing the calculations here in a totally different gravity.
There must be a calculation of how much oxygen they needed and the weights of the cylinders and how did they get all that up there, for God's sake?
I can give you the maths for that.
Why does it even matter that they said they lost it? I mean, for the sarcasm that we're bringing right now around it, it's like, bro, they didn't go because...
Sometimes it's better to say that you lost it than to create some fakeness that could be actually seen as fake. So
oh,
you just,
what Hollywood sentiment? It is better to have loved and have lost than to have never loved at all, right, Chocolate?
there you go.
That's right. You know something? I said that to somebody that just lost a very close pet, and my wife got on me for saying that. I'm like, what are you talking about? That's the perfect thing to say.
Yeah.
It's better to have the illusion of going to the moon and not be able to do it anymore than to have never been at all.
Exactly. Exactly.
Nathan,
Now you put it. Look how many people are prideful, right? There are Americans that are prideful. Oh, we went to the moon, like a sports team or something. Yeah, we did that. Yeah, all right.
That's what I said. Patriots.
Go on, 10th.
Nathan, I got that timestamp on that video. It's from 33, 32 to about 35 mark. Can you just play the audio without showing the video and in full? It's pretty good. But the video shows him doing the gyrations with his hand, and he's got a grease board, so it's kind of nice.
Who is it? What's the video? What are we talking about? I've lost track of what I'm supposed
This
to be.
This is a YouTube channel who's describing celestial navigation.
Okay.
33 minute, 32 second mark. It goes just past 35 minutes in full.
Okay, I'll see if I can cue it up. Just give me a couple of seconds. I've got to skip past
Sure.
that. 32.
Is there any copyright problems with that?
Probably.
That's the start of your diagram. Try to get that on the paper. Center of the Earth. Joe here with the star right over his head. The two parallel lines of light coming in. Make sure this line of light and this line of light are parallel. And then this line is just a line from my position down to the center of the Earth.
Okay, so do you want to contextualize this? 10th.
Well, he's describing how light comes in, and he's trying to show how celestial navigation works on the surface that's curved. But as he's about to explain, he's going to be drawing a tangent plane very soon and describing what horizontal is. And this is where he does his little hand movements, where he wants to say flat in my mind, but that's just my opinion. But
now,
he can't say it. So
when we shoot a star, when we use the sextant and shoot the star, we're shooting the height of the star above the horizon.
Yeah, so what he's showing is a flat plane and his hand making the angle to the star. Is that what you mean?
But keep going. It gets better.
So we take it and we get the angle, that we look out at the horizon, and then we look at the star, and we see how high the star is above the horizon. Let's say it's pretty high. Let's say it's at like 50 degrees. The star is up about 50 degrees above the horizon.
You'll need a flat plane for that.
What is our horizon?
Definitely not Earth curve.
Here's the starlight. What's our horizon in this diagram? Well, think of the horizon as a pretty clear word. Horizon, horizontal.
So we're not thinking about it as being a physical geometric sphere edge limitation to block boats and buildings then. We're just thinking about it being horizontal. Okay, I gotcha.
Everything that's horizontal that's what the horizon is, horizontal.
Okay, gotcha. Horizontal, horizon, gotcha. We all clear on what he's saying? We're not talking about 8 inches per mile squared dropping away. We're talking about being horizontal. We all clear?
Yes.
Exactly.
Clear.
Okay, let's just continue.
Vertical is straight down to the center of the Earth. For my position...
Whoa. What? Vertical is straight down to the centre of Earth? Why has he dropped that in there, 10th? I don't follow.
Well, you'll see in a minute, because he changes it up when he draws the tangent plane.
Let's have a look.
This line represents vertical. So that's a vertical straight down to the center of the Earth, straight down through my feet to the center of the Earth. That's vertical. Horizon is horizontal. Vertical and horizontal are always perpendicular to each other. So if I want to add the horizon to this diagram...
Hold on, he just said they're perpendicular to one another, right? Well, if that's the case, then that immediately violates having a curved surface.
Yeah.
Okay, let's continue.
I just need to do a line that's, see if I can do a straight line here, a line that is perpendicular to the vertical. And that line just barely touches the surface of the earth right where my feet are. And that is actually my horizon.
So not this tangent point dipping away 8 inches per mile squared, not the surface of Earth being a sphere edge horizon then. He's saying just imagine the horizon as a flat plane and then put it on the surface of a ball where it just touches it but isn't the surface of the ball. But the horizon is giving us this horizontal. So we're looking at the ground and it's giving us a straight line, and that's not the curved surface of the Earth. Everyone clear so far?
Yes.
Okay. A little bit more?
A little bit more.
It's actually my horizon if my eye level is down right at water level. There's a minor correction when I'm up in the cockpit of my boat and my eye might be 8 feet above water level. There's a minor correction because then I'm looking down on what the real horizon is. I'm looking down and the horizon's a little farther out. But basically for now...
So what he's describing is Brian's description, or your description, of height above the flat ground with eyes against it. But he's correcting because he's slightly above. He's not correcting from a physical geometric sphere edge horizon dipping away at 8 inches per mile squared, is he? He's saying you're correcting against something that's parallel with it. Correct?
Yeah, correct. He pretty much destroyed the globe Earth right there in one presentation.
Epic. Is there any more?
No, I think we're done. I'm just going to post that picture earlier this morning. I'll put it up right now in Master B so you don't have to search for it. And I think it lends a lot of credibility to it. Hold on one second.
Is it the picture of the box with...
It's the picture. Well, you could do that one, but it's the picture of the submarine and read what it says.
Okay. It's the one with two images, one above the other.
Yes.
Okay, I've got it up.
Yeah, let me get to it myself so I can read it for you. All right. Oops, I overshot it. Observer horizon, geoidal horizon. Figure 2.7, the Nautical Almanac and the site reduction tables assume that the sites are taken at sea level. For instance, from the periscope of a submarine barely emerging above the water. Second one, the height of the observer eye above sea level determines the dip. This angle must be removed from the altitude of the celestial body above the horizon as measured with a sextant to obtain the apparent altitude. Sea level, the surface of Earth, flat, horizon, angle, can only be achieved if you have two straight lines, not over that dingleberry. That's why they draw the tangent plane.
Epic. Yeah. You need a flat plane. It's as simple as that. And if you haven't got one, you'll engineer one off a surface that isn't being used to get the angle. So it's just a justification with the begging the question fallacy. Well, my zenith goes straight through my head into the centre of the sphere Earth, I'm assuming, but not utilising or measuring anything from. It's just getting in the way.
Yeah, they don't go to the center to get the other part of the angle. They do it from the surface with a tangent plane. So everything below that tangent plane is irrelevant. You can put a triangle there. You can put a hexagon there. It doesn't matter. It's never used.
Perfect. Thank you, Tent. Good way to round that out.
Yeah. Thank you.
Any more comments? Any more for any more?
He did me yesterday on that. I assume it was for. Well, just one thing. Did you see the? There is a flat Earth link to it, but it will take me a sec. But it is Johnny Depp and Amber Heard related. Did you see the link? Yeah. I sent you a link yesterday, didn't I? I said, have a laugh, 33 minutes on. It's just another YouTuber, Coda Miko, doing it. Very funny because it's from a woman's point of view, and I've never, if a man was saying those things, it'd be, I think, a different response in terms of it. But she's the woman that contacted me via Twitter, saying, "Do you want to discuss flat Earth?"
Okay.
I've said yes, but I've still awaited. I mean, it must be 4 or 5 months now, but it might be worth just
giving her a tap.
Yeah, give her a tap back, but just have a little look because she's on back generation 4 now, but it's all CGI based thing, and the level of animation on her now is pretty cool compared to the early stages. But
what's the name again? Plug her again.
It's Coda Miko. I've sent you the link yesterday.
I'll check it out
because she's reviewing the trial, and she's very funny as well. So
cool.
I'm very suspicious because the video I posted, I said timestamp 33-minute mark. Adam comes and says timestamp 33-minute marks. Is something going on here?
Last night when I typed
Illuminati confirmed.
Indeed. But with that, I'm going to say a huge, massive, enormous thank you to both Discord and Tubeless Panels for making today's after show possible. And of course, a massive thank you to all of you in either Nathan Oakley 1980 or Nathan Oakley Premiering streams for hopefully smashing the super chat, liking, commenting, sharing, subscribing, hitting the thanks button, hitting the PayPal link, and all that good stuff. I've been Nathan Oakley, and I will see you all in the next video.